Welcome back to the final project of this course. And in this one, we take everything that we learned throughout the course and put it all into one beautiful, modern, and really advanced application. So we're going to use things like classes, modules, promises, async await, parcel, and so much more. Also, we're going to dive even deeper into flowcharts and project architecture in this project so that you become more and more confident and prepared to actually write applications by yourself. So this will be a ton of work, but also a lot of fun. And so I can't wait to finally show you this project now. Hello and welcome to the biggest and most complete project of the course. And this is kind of the final project of this course, which brings everything that we have learned up until this point into one big and beautiful project. And so just like with the MapD project before, let's actually start by taking a look at this project. And this is it. So this is the Forkify application that we will build together over the next couple of hours. So this application is all about searching for recipes and displaying them here in our user interface. And in order to get a good idea of how this application actually works, you should probably follow along this demonstration by going to this URL. So Forkify v2.netlify.app. And so let's start for pizza here. And so you see that right away here on this left sidebar, we get all of these results. And when we have more than 10 results, they actually get divided up on multiple pages. So we have this nice pagination here, which is a very common feature of web applications, right? So you've seen this all the time probably. And so now in this project, you will learn how to implement this yourself. Now, okay. And now let's actually click on one of these recipes, and you see that then it shows up here on the right side. So we have the cooking time, the servings, all the ingredients, and then also a link to the page where the recipe actually comes from. Now here in the servings, we can actually decrease or also increase the number of servings. And as you see down here, the ingredients will then automatically get updated. Right? Then another cool thing that we can do is to bookmark recipes. So as we click here, then that button changes, and we also got that recipe bookmark here in this nice panel now. And here you see I already had a bookmark before, and as we click that, it will then of course move to that one. Now if we click here again, then that will basically unbookmark the recipe. And so you see that now it's gone. And let's do the same here. And so now it's empty. And we get this kind of warning message instead. All right. Now finally, we can actually also add recipes. So just click on this button. And then here we can just fill in this form. Now in this demo version, that's actually not going to work because that would very quickly clutter this entire application here. Now, what's special about this recipe upload is that all the recipes that you upload yourself will only be visible for yourself. So here, for example, I have this JS pizza, which was done by me. And so therefore it has this icon here and also this icon here. So it means that it was the user itself. Now, when you open up this page and search for pizza, then this recipe here should probably also appear for yourself, but that's only because this version has like a fixed developer API key. And so each recipe is associated to a certain developer key. And we will see what that means by the end of this section when we actually implement this. All right? But I think that's actually it. So that's the whole functionality of the Forkify application, which seems pretty simple, but it will actually be a lot of work to implement all of this. And so hopefully it's going to be a great learning experience for you. And once again, I tried to design this application like as modern and beautiful as possible so that you end up with a real nice application in your portfolio in the end. Okay, but with all that being said, let's now actually go plan this application. So now that we know what the project looks like and also how it works, we need to go through the same planning steps that we did in the MapT project. Now in this case, we will actually leave the architecture for a bit later and only talk about the user stories, features, and also about the flowchart for now. And to start, remember that a user story is a description of the application's functionality from a user's perspective. So basically, when we write user stories, we need to put ourselves in the shoes of our users. Now, all the user stories put together will then provide a clear picture of how the whole application is going to work. And so based on these stories, we will then be able to implement all our application's features. All right, so let's say that we are now kind of the project manager for Forkify, and let's also pretend that we didn't see the final version of the project yet, because of course we have to write user stories usually before we implement the project, right? But in this case, since we're kind of doing it together here in this video, of course it's better when we already know what the application looks like. But in the real world, this is basically going to be your starting point. So for this project, the first user story could be, as a user, I want to search for recipes so that I can find new ideas for meals. And so you see, again, we are using the format of as a type of user, I want to, and then an action, so that, and then a benefit. So here the user wants to search for recipes so that they can find new ideas for meals. Then next up, the next user story is, as a user, I want to be able to update the number of servings so that I can cook a meal for different number of people. And that of course makes a lot of sense in any application of this kind. Then next, as a user, I want to bookmark recipes so that I can review them later. And again, this really makes sense in any kind of real-world application like this. Then, as a user, I want to be able to create my own recipes so that I can have all my recipes organized in the same application. And finally, as a user, I want to be able to see my bookmarks and my own recipes when I leave the application and come back later. And so this way I can close the application safely after cooking. All right, and once again, let's kind of pretend that we came up with all these user stories while kind of brainstorming for this application. And so now we can use all these user stories for our next step and come up with the features that we need in the application. So first, the user wants to search for recipes. And so therefore, our application should have a search functionality, which is basically an input field which will send requests to an API with the searched keywords. Then the application should of course display these results and also with pagination to make it more user-friendly in case that there are many results. And then of course the application needs to display the selected recipe with relevant data such as cooking time, servings, and ingredients. Now the next user story is pretty simple, so all we need is a functionality to change the servings. So basically updating all ingredients according to the current number of servings. Then in order to bookmark recipes, we simply need a functionality for that. So basically allowing users to bookmark the recipe and then display a list of all of them somewhere on the page. Then for the next user story, what we need is basically a feature that allows users to upload their own recipes, which should then automatically get bookmarked so that the user can easily find all of their own recipes. Now, what's important here is that each user can only see their own recipes, but not the recipes from other users. And we could go ahead and implement this in a very complex way, like, for example, creating user accounts, but we will keep it very simple and basically simply associate uploaded recipes to an API key. And again, we will see by the end of the section how that is going to work. Now, finally, we are going to need a feature that will store bookmark data in the browser using local storage. And that we already did before, and so this part is going to be fairly simple. Then to finish, whenever the page loads, we need to then read all the saved bookmarks and display them somewhere on the page. Great. And with this, we now know exactly what we need to implement. But now let's take this list of unstructured features and actually put it into a nice structured flowchart, which will allow us to plan how exactly the application is actually going to work. So we're going to start only with these first 3 features in order to keep it simple now and not overwhelm you right from the start. So we're going to build this flowchart in 3 parts, and now starting with these 3 features. And as always, we're going to focus on events, and the first event in our web application should probably be the user searching for a recipe. And so that's our feature number 1, basically. So when a user searches for a certain recipe, then we need to asynchronously load the search results from our API. And so, of course, that happens asynchronously. And then once the results are in, we will simply render them in our application. However, we will not render all the search results right away because that would be overwhelming. And so instead, we also render some pagination buttons in order to hide basically part of the search results on different pages. So that makes sense, right? And then as the user clicks one of the pagination buttons, it will then render the search results for the new page that was selected, basically. And it will also render new pagination buttons. So for example, when we're on page 2, then there will be a button to go back to page 1 and a button to go to page 3. But when we're on page 3, then the button to go back will point to page 2 and the button to go forward will point to page 4. And so we need to re-render these buttons basically every time that the user clicks on one of them, right? Then finally, we also need the logic to actually display the recipe. So when the user selects a recipe, then we need to asynchronously load all the recipe data from the API, and then once the data arrived, we render the recipe to the user interface. And we will actually also do the same whenever the page loads with a recipe ID in the URL. So I think I showed you that in the beginning of this video. So whenever we click on a recipe, then the URL will change with the recipe ID. Remember that? And so it's important that, for example, if we take that URL and copy it and paste it, for example, to another browser, that then the recipe corresponding to that ID should also load right away. And so that's why here in this flowchart, I have the load recipe on both events. So when the user selects a recipe from the user interface, or also when the page loads with a recipe ID already in the URL. All right, and that's actually it for part 1 of the flowchart. And in fact, these are basically already our core features. So the most important features of the application. So searching for recipes, rendering search results, and then also rendering the individual recipe that was selected. And so all this will probably take us half of the section to implement. So there really is a lot to do. Now we will start implementing the project only with the recipe displaying. So only feature number 3, which is basically this right part of the flowchart. And this will allow us to start implementing some functionality and also play around with the application a little bit, but still without thinking about the architecture. and so without the rigid structure that might be imposed by the architecture. Great. So with this, we basically have this part of the application planned, and so let's now finally get to work. All right, so let's set up our project and also start to load some recipe data from the Forkify API. And here, as always, I already have the starter files loaded. Now this time we have a bit of a different structure here. So I have index.html out here, but then all the rest of our assets for this project are here in this source folder. So in the source, we have images, JavaScript, and Sass. So for JavaScript, right now we have controller.js, which contains this little starter code here. And then I have this Sass folder. And in case you don't know, Sass is basically a better way of writing CSS, which has some nice additional features, which makes writing CSS in a large-scale application a lot easier. Now, browsers actually don't understand Sass, and so it has to be converted to CSS. And so Parcel is going to do that for us. And so I left these Sass files here so that you can see that Parcel is actually also capable of doing that. All right, and then here, just some images. And of course, down here, we have our flowcharts and also a small diagram about the architecture. Okay, but now let's open up a new terminal here. And then just like before, we need to initialize a new project by writing npm init. And so this command will then create our package.json file. So this project should be called simply Forkify. Then the version might be version 1. Here, let's just say recipe application, or really whatever you want. Then this one doesn't matter, neither this one. And now you can just add your own name here if you'd like. And so that's it. And so again, this now created this package.json file right here. Let's get rid of this one here actually. Or actually, let's just change it to .html. So this is kind of our entry point. So let's specify that here, even though it's not really important. And here I will start by setting up the npm scripts now. So just as we did in the last section. So this one is going to be npm start instead. And here we will want to start Parcel on index.html. So index.html is again going to be our entry point. And then since we are here, let's also already add our build script. So basically the command that we are going to run in the end once we're ready building the application. And again, index.html. Now, sometimes in projects, we don't even have an HTML. And so, of course, the entry point can also be a JavaScript file. And also this could be in a different folder. And we can specify all that here in the Parcel command. But once again, we are just keeping it very simple here. Now, in order to actually run Parcel, of course, we need to install it. Now, in the last section, we simply installed Parcel by writing npm install Parcel, and then as a dev dependency like this. And so this would then basically install simply the latest version that is available on npm for Parcel. And at the time I'm recording this, that is version 1 point something. However, Parcel 2 is almost ready at this point, and so I want to use a beta version of Parcel 2 so that you can use Parcel 2 in the future. All right. So if Parcel 2 was already out, then we would simply write add 2 like this. However, right now it's just a beta version, and so I have to type add next and then add it as a dev dependency. So again, I'm writing add next here to install a beta version. So let me run this, and in case that you get any error, then please go ahead and simply install parcel at2. So you see here that this is going to install at 2.0.0 beta 1. Okay, and here we go. So again, you see that we are at version 2 beta 1. And if you got some error here, again, then please try parcel at 2. So it's really important for the rest of this section that we are actually all on parcel 2 dot something. So here it doesn't matter if you have 2.1 or 2 or 3, but it should be 2. So that's what matters from this part. And so now let's actually start parcel by running our npm script, npm run start. And actually the start script is a special one in npm, for which one you don't even need the run. So you can just write npm start, and that will then call your start script. All right, so it's installing Sass, and now we get this error here for the module Sass. And so let's quit this here with Control C, and then I just say npm install, and so this will then install Sass here for us. But if you're still running into some kind of error with Sass here, then please just try to install Sass using the exact same version number. So npm install Sass and then at 1.26.10. And so that should then fix any remaining problem. And if it didn't, so if even after that you still run into some problems either with Sass or with installing parcel or running parcel, then please take a look at the frequently asked questions in the GitHub repo. Okay? And only in the last case, you can of course also ask in the course Q&A section. But anyway, if we now try to run npm start again, then it will work. And indeed, here it is. So we now have the node modules folder, which contains, well, tons of modules. And then we also have our distribution folder, right? And you see that here everything is in one folder. So our index.html, and then also the controller script, which is this one. Well, not really this one, but the compiled one. And also you see that now we have an actual CSS file, and you also see all the images. So a real CSS file. Let's take a look at index as well. And so you see that now it replaced the controller.js here in the source. And also here I was referencing the SCSS file, so the Sass file. And it is because of this that Parcel actually knows that it needs to compile the Sass file to CSS. So basically I referenced this Sass file here, and therefore Parcel knew that it had to include that file in the distribution as well, and to also replace then the link to the actual final CSS file. And the same is true for all the images. So it basically copied all the images to the distribution folder and gave them a new name and replaced their source here in the HTML. Okay? And this is very important to keep in mind as we go building this project. But of course, this folder here is not really important for us in development. So everything we will develop will be here in the source folder, and only what we then see in the browser is actually coming from this distribution. So again, that's the whole logic of having a module bundler. So it takes our basically raw source code and compiles it into this nice package here, let's say. So this folder that is ready to ship to browsers. Okay? So for now, we no longer need this HTML file. And so we can now think about our controller here and actually think about making our first API call. And we can actually also open the page here by clicking Option and then here. Well, that opened in another tab for me. So let me just copy it right here. Okay, let's open up the developer tools as well. But for now, of course, we have nothing here because we don't have any code yet. But let's just log something to the console just to see that our parcel setup is working. And you see that it already built a new version. And indeed, we have test now in our console. Great. So everything is working. And so, yeah, let's now make our first API call. Now, for this project, I actually developed my own API so that we are not dependent on any third-party services. And the API is at this page. So let's copy it and let's go there to check out the documentation. So any good API needs some sort of documentation. And so this is the documentation that I wrote for our Forkify API version 2. So version 1 was for the old version of this course. So some details about this API is that search terms are limited. All you can search for is the terms that are in this list here. But to test this application, that should be enough. And you can only make 100 API requests per hour in order not to overload our servers. Because again, this is here my own API that I'm running on my own server. Then the API key is what we will need to upload our own recipes. But again, more about that later. And then here we have basically our main URLs or routes of this API. So the first one is used to get all the recipes or to create a recipe. But for now, let's focus on this one, which is simple to get one single recipe. So the path of this part of the API is this here. So this URL then /recipes/the ID of a recipe. And down here is an example of that. So for example, this one here might be the ID. And then here the key, but again, the key doesn't matter for now. And we can click on this and then see exactly the kind of result that we will get. And so actually, this is the URL that for now we will use in our code to basically get exactly this recipe here in our application. So let's copy this and go back to our code. And so now, as always, to make an AJAX request to an API, we use the fetch function. All right. And now that we have this, let's actually create some function around this. So an async function so that we can use async await. So let's call it show recipe. So an async function. And then here, as always, we use a try catch. And if there is an error, we want to alert that error. So very simple error handling for now. And now let's take this here and await it and store the result into the res variable, which stands for response. And I hope that all of this here is nothing new for you at this point after the last couple of sections, right? So just keep in mind that using the fetch function here will return a promise. And so since we are in an async function, we can then await that promise. So basically we will stop the code execution here at this point, but that's not a problem because this is an async function anyway, which only runs in the background. So we are not blocking our main thread of execution here. But anyway, once we have that result, we then need to convert that to JSON. So as always, let's create a data variable and then await the response.json. So the JSON method is, again, a method that is available on all the response objects. And a response object is exactly what the fetch function here returns. And so, yeah, we can then call JSON on that response, which returns another promise, which we then have to await again And in the end, we will then get our data stored to that variable. Okay. And then let's actually console.log both the response and also the data. So give it a save. And we also should call this here right at the beginning, because otherwise nothing is going to happen. And so, which one is ours? Here we are. Okay, and you see that we already have a result here. So first is the response. And so again, as I mentioned, this returns a response object. But then the data itself is here. And so we get this status here, and then the data itself. Make it a bit bigger here. Okay. And so then here, inside of data, we get the recipe itself. Okay. So it contains all of this data here, cooking time, the ID itself, then the ingredients, publisher, servings, and so on and so forth. So that works beautifully. And as always, we started here assuming that there will be success. But now let's try to create a wrong ID here, which doesn't exist on the server. So just something like this. And let's see what happens then. And so you see, we get the bad request. Here then in the response, we can see that OK is set to false. And so this is what we're going to use. Remember that? So when OK is set to false means that there was some kind of error in the fetch. And so we can then use that to create our own errors. So again, just like we learned in the asynchronous JavaScript section. Okay. But then we still get a response here. And this response says fail. And then also this message of invalid ID. And then the ID that we provided. So also the API itself returns a nice error message. And so let's actually use that error message now. Okay, because simply bad request is not a very informative error message. It's way better to actually use the one that the API returned to us. And so that's at dot message of this object. So we need to do that after this one here. And so we can say if response.ok is false, so basically if response is not OK, then we want to throw a new error. And then in there, we can use the .message property that I just mentioned. And again, that one is already coming from the data. So from the response of the server, while the OK property is stored in the response itself. Okay, and then let's also provide the status code. So that is at response.status. Okay, and you see that somehow we already get the error here, even though we're not at Chrome. But anyway, that alert window appeared, of course, because down here in the catch error, we are alerting exactly that error that we throw here in the try block. Right? And so as we go here, let's just try to reload. And so indeed, here we get our error as an alert window. Okay. But now let's take it back actually. And so when we're back, then our data here is also back here. Okay. Now just to finish, let's actually format that data a little bit nicer. So basically I want to create a new object based on this object, which has some better variable names. So here we have, for example, these underscores, and these are very unusual in JavaScript. And so many times what we do is to basically kind of reformat this object that we get here. So basically I want to get rid of these underscores. And so let's create a new recipe variable, which should be data, And then remember that it is again data and then dot recipe. So let's see that again just to make sure. So this here is the data variable, and then in there we have data again, and then in there is dot recipe, right? And so here we have recipes on both sides, and so we can use destructuring. So let's take that back. And I called this one a recipe with let, so that we can now basically create a new recipe object based on that. So the ID is recipe.id. The title is going to be recipe.title. The publisher will be recipe.publisher. And there would have been other ways of doing this, but this is kind of the quick and dirty way. So source URL is going to be recipe.source and then underscore URL. So this is one of the ones I wanted to change. Then there's also an image URL property, and this one I want to simply call image. Image URL. Then the servings might be just recipe.servings. And we're almost done here. So cooking time is recipe.cooking time with an underscore. And finally, ingredients is recipe.ingredients. Okay. Now let's actually get rid of this and simply log to the console the recipe object that we just created. And here, ingredients looks wrong. Ingredients like this, and here the same. Everything else looks correct. And yeah. So here is our nicely formatted recipe that we just got from the server. And of course, that would work for other recipes as well. So let's go back to our documentation page and get some other ID. And so that ID we can basically get from this search URL. So this path here will take us to all the recipes there are for a certain search query. So let's try this one here, which is for pizza. So you see, it is the route, so the URL that I just told you, /recipes. And then we have this query search set to pizza. So after this question mark. And this is a very common format of basically sending variables over URLs. So search is like a variable, and then pizza is that value. And so in this case, this is the query string. And in this case, what we want to search for is pizza. And so let's now just take any random ID of these. So just copying it. Let's go back here. And then I will just duplicate this line and comment it, and then replace this part here of the URL with this other ID. So you see it's slightly different, and so now we should get a different recipe. So let's see. And yeah, this time it is called pepperoni pizza burgers. And so of course, later in the real world, we will then get these different IDs from our search results here in the sidebar. Okay, so we successfully started up our project and already did our first API call to the Forkify API that I created just for this project. So this was a nice start of the project, and now in the next video we will then actually already render this data to the user interface in order to create something like this here. And I hope you're excited for that, and so let's quickly move on. So after loading the recipe data from our API, let's now render that data in our application. And for that, let's go to our HTML file to basically get the template from there. Let's close down this terminal, which will keep working in the background. And so here is the results part, the pagination, And then here we have the recipe class. So the recipe class is basically this whole container. So here in this case, it's this whole gray container, which is the one that will contain the rendered recipe. Okay, then right now it has that message. So again, it is this message here that is already rendered there at this point. Then here is the code for a loading spinner, for an error, and then here actually for the recipe itself. So here we have that image, and then all of the information about the recipe itself. And so it's all of this code that we need now. So let's grab all of this commented out code and copy it and paste it here into this function. So let's add a comment here. So loading recipe, and then afterwards, as step number 2, rendering the recipe. And for now here we are doing this like really big function, but of course once we start thinking about the architecture, we will then break this up into functions and modules and classes and so on and so forth. And so, as always, doing a big template literal here, just as always, so that we can then replace all the data here that we need. Just fixing the indentation here now. And so now let's take all the data that we need. And the first one here is the image. So let's replace this string here with recipe.image. So just like we specified here. And so this image property is basically a URL which points to the location of the image on the Forkify API server. Then here we have the recipe title. So this one here. Dot title. And actually we also have that title here as an alt text of the image. Okay, then here we have the clock. So this 45 here is the cooking time. So recipe, and missing the block here, dot cooking time. Then down here we have servings, and so that's this number here. So number 4 will now be replaced with the data coming from the recipe object. So recipe.servings. And let's keep going. So down here we have the ingredients. So for each ingredient, there will be one list element of this. So in this example, right now we have 2 list elements and 1 for each ingredient. But let's actually keep that for later. And for now, keep filling the rest of the data here. So this is the next piece of data, which is the publisher. So here it says recipe publisher. And so let's change that to recipe.publisher. Then here we have the source URL. So let's take a look at that, maybe here to make more sense of this. So we used most of this data here already. So here is the URL to the recipe itself, where it actually comes from. And then about the ingredients, as you see, it is one array, and each position of the array contains one object, which contains the quantity, the unit, and the description of each ingredient. And so we will have to basically loop over this array and then use all of this data to create one list element for each of them. Okay, but for now, let's go back and finish the data here. And in this case, replacing this URL by the one coming from the object. So that's recipe.source URL. And so except for the ingredients, that's actually it. So yeah, before we can check out the result, of course, now we need to actually insert this HTML into our DOM. So for that, we can use the insert adjacent HTML method, and we need to do that on the parent element, remember. And I already selected that up here. So remember, that's the element with the class of recipe. So just to remember, it is this div element. So that is called recipe container. And so that's where we want to attach this HTML markup. So recipe container dot insert adjacent HTML. Then let's do after begin. So basically as a first child, and then the markup variable that we just created. And that should be it. So this should now render the recipe in the user interface, except for the ingredients. And indeed, that's looking really nice already, right? So the ingredients are still the old ones, but the rest is really nice, except for that we have still this message here from the beginning, and also that we are missing all the icons. So you see, there are no icons to be found here. In the real one, of course, there are icons all over the place. So we have three problems here. We have this message showing, we have the ingredients, and we have the icons. And let's start with this message and then the ingredients. So before we insert any new markup, we need to get rid of the markup that is already there. So let's simply do recipe container dot inner HTML and set it to nothing. So emptying it out. And so you see, now it is gone. All right. So let's now worry about the ingredients. And again, we will need to loop over the ingredients array. And for each of them, we should then create this kind of markup here. So how should we do that? Well, basically exactly what I just said. So we take recipe dot ingredients, and then we loop over that using some array method. But what array method should we actually use? Well, remember that in the end, the expression that we need here needs to return a string of HTML. And so that means that our array method needs to return something. So for each is not the way to go here. So not for each, right? But instead, we are going to use map. So map returns a new array with the same length. And so that array we will then in the end be able to simply join. And so now we can loop over the array by specifying a callback function. So each element is going to be called ingredient. And then here we can do something. So let's simply replace a string here. Right? So taking this and put it right here. And then of course we don't need this one anymore. Okay. Then here we have some kind of error. But never mind. Let's think about the data here first. So let's take a look at the data actually again. So at the array. So each array element is an object which has quantity, unit, and description. Okay. So this ingredient is now that object. And so here we can say ingredient dot quantity. Then here the unit. So ingredient dot unit. And then finally here, instead of pasta, we want the ingredient dot description. And so now here we will have an array in which each element will contain this markup corresponding to the ingredient. And so now all we need to do is to transform that array of strings into one big string. So we can take the result of this map, which is that array, and call join. on it like this. And so now the result of this entire expression is going to be a big string containing all the ingredients. So if we give it a save now, then indeed, here we have our 8 ingredients. Okay, so that's pepperoni pizza burgers. And now, remember we have a second one here, so let's switch them out again. Give it a save, and now we get, well, this pizza here. And so indeed, it now has different ingredients, different publisher, and everything is different. Great. But now there is one thing missing, which is the icons. So let's see why that is. Well, remember that the page that is displayed here in the browser is this HTML here from the dist folder, right? And so remember that all the images and really all the assets are now coming from this folder. And that includes the icons. So our icons are always coming from this icons.svg file. But now the icons are actually coming from icons.all of this here. And you can see that, for example, right here in the search bar. So icon search is coming from icons.96 and so on and so forth. However, in our template literal, we are still writing basically the old path to the icons. So this one here. And so right now, JavaScript will not be able to find this. So in the dist folder, this one here, there is no source /image folder in which there is icons.svg, because that exists only in our source folder. So only right here where we are developing the application. But again, right now, we are basically shipping the application already. And so it's using the data from this dist folder. And so now we need a way of telling our JavaScript that the icons file is no longer this one, but instead it is this one. And we can actually do that with Parcel by basically simply importing the icons file. So let's go to the top of our file, because I like to keep all the imports always at the top. And so again, in Parcel, we can import more than just JavaScript files. We can import all kinds of assets, and that includes images. So let's import, and let's call it simply icons, but this name can be anything that we want. From, and now the path to the original icons file, basically from the view of this controller file, right? So here we are in controller.js, and so now we need to find the path to the images. So to this original icons file. So we need to go one way up. So exactly the way we browse the file tree in the terminal. So ... always means the parent folder. And so right now we are back in the source folder, which is the parent of JS. And then from there, we can go into images and then icons.svg. All right. Now, this is the way it used to work in Parcel 1. So if for some reason you are running Parcel 1, then this is the way to go. But in Parcel 2, it works almost the same way. But then for any static assets that are not programming files, so for any like images or videos or sound files, we need to write URL, then colon, and then the path to the file. Okay, so let's take this out. And then let's log this icons to the console so that you see what this icons really is. Because in fact, it is nothing more than simply the path to the new icons file. So the localhost 1234 is in this case basically our dist folder. And then in there, the file that we need is icon.96f and so on and so forth. And so that is exactly this file here. Okay? And so now let's use that. So everywhere it says icon, so everywhere we have this old path, we now want to replace it simply with the icons. So let's select all of them using Command or Control D. Or if that doesn't work for you, you can always probably use Command F or something like that. But anyway, now we have all of them selected at the same time. And then I can delete them all and then insert the icons variable here everywhere. And so now, if we give this a save, then our icons are back, right? So starting here, then in all ingredients, and here also all over the place, we now have our icons back. And now just to finish this lecture, I want to give this one more touch, which is this here. So watch what happens here in the recipe when I load the page. Well, that was pretty fast. Let's see again. So maybe for half a second or so, you saw a loading spinner there. And so that's what I want to have here as well. So before the recipe arrives, I want like a loading spinner there, because that's a very common pattern that you see in all kinds of applications, right? And it's actually very simple. So we have the code already here in our HTML. So it is this spinner here. So let's grab this code. And then here I will simply create an external function called render a spinner. And let's make this a very generic function that we can reuse. And so let's pass in the parent element. And so then we can simply attach this to any parent element that is passed in here. So as always, creating a markup variable. And then our code here. And just like before, we need to now replace this old path with the new path. So icons. And then, of course, we need to add this HTML to the DOM as a child of the parent element in this case. So parent element dot insert adjacent HTML after begin and markup. Okay, and now let me just quickly show you why this is going to work. So here in the CSS, let's look for spinner. And here you see that the icon inside of the spinner class has this rotation animation that keeps going forever. So that's this infinite attribute here in the animation property. And this rotation animation I created here manually using keyframes. And basically what it does is to rotate the element to 360 degrees. And so if you ever need a spinner like this, you can simply basically copy this code here. All right. Let's close what we don't need here. And probably before we insert this, we should also clear the parent element. So just like before, setting the inner HTML to nothing. And now let's actually render the spinner. So let's do that here as we load the recipe. So right here. So render spinner, and then the parent element in this case is going to be the recipe container. All right, let's go back and reload. And there it was. You saw it. Let's make this a little bit slower by changing our network speed here. And so it took a little bit longer, maybe slow 3G is going to be even better. And so now it's going to take a lot more time. But indeed, here it is. So that spinner is a nice touch, I think. And it definitely makes this application feel more real world. Now, just to finish this video, something that I should have done in the last video already is to add polyfills for ES6 features to our code base. So just like we did in the previous section as well. So remember to do that. We installed some special packages. So the packages are called npm core.js, and we can actually install multiple packages at the same time. I think I never did this before. So this is how it works. Regenerator runtime, and then hit enter, and then let's wait for these packages to download. And here they are. So they should be, yeah, so right here. And now all we have to do is to import them here at the top of our file. And so with this, we make sure that most real old browsers are still being supported by our application. So actually, we don't even need to save it anywhere. We can just say core.js and then stable. So VS Code, one more time, is really smart and can really help us with package imports like this. So again, this one here is for polyfilling async await, and this one here is for polyfilling everything else. And we could just cherry pick some features and only import those, but let's simply polyfill everything. Okay, don't need this terminal anymore. This one here already reloaded. And you see, everything keeps working the same. All right. So we have this working. Now in the next video, let's quickly add some event handlers so that after that, we can start talking about the architecture. Let's now add some event listeners to our application and kind of simulate that we already have some search results in place. And let's start by taking a quick look at our flowchart here. So we already implemented this part here of loading a recipe and also of rendering it. But now in this lecture, we want to also hook up these two event listeners here so that the recipe is actually loaded on one of these two events here. So when the user selects a recipe from the results list, or when the page loads with a certain recipe ID. Okay, so let's do that. And let's also take a quick look here at the demo version. So searching for pizza again. And let's click on any recipe here. And so again, here you see that we have this hash. So everything that comes after this hash symbol here is called the hash. So this is the ID of the recipe, and all of this together is called the hash. And the way this is going to work is that whenever this hash here changes, a new recipe is going to be loaded. So if we click here now, watch what happens there in the hash. So you see that it changed. And that changing of the hash is actually an event that we can listen for. So again, the hash here now changed, you see. And so we can then listen for that event, take the hash, and from there take the ID, and then load the recipe with that ID. Okay, did you follow that? And if not, that's not a big deal. So let's just see in code what I mean by that. And to start, we actually need a way of triggering a change of the hash. All right, and we can do that by adding a fake link here in the search results. So let's simply add a link here with the href of hash. And then here as the hash, let's actually copy this one. And you can copy any other ID. This doesn't really matter. This is just to show you how we can listen for the event of that hash changing. So give it a save. And so here now is that very small link. And watch what happens when I click here. So you see that the hash changed, right? And actually, let's add another one here. So 1 and 2. And now here from the controller, I can get one of these IDs. So let's say this one and put that one here. So these are two IDs of two different recipes. And now as we click each of them, you see that the hash up there in the URL bar keeps changing. And so again, we can listen for that event. And so let's do that now. So let's come down here. And then window.add event listener. And the name of the event is called hash change. Okay? And the function that we want to run then is show recipe. So let's remove it from here and only run the show recipe function whenever that hash changes. However, that is not really helpful yet, because the next step is that we actually need to get the recipe ID from the hash, right? So let's go up here. And so let me just show you what I mean. So right now, when we click here, then some recipe will get shown. So you see that it loaded this spicy chicken, but now if I click here, then it will load the same one, because we are still hard coding this ID here. But instead, here we want to show the recipe with this ID and here with this other ID, right? So we want to dynamically get the ID here from the hash. And that's pretty easy to do, actually. So we can actually do that out here of the try, or we can also do it inside. So that's not really important. So let's say the ID is window.location, which is basically the entire URL. And then from there, we can take the hash. Now that's not yet everything, but let me show you what the ID looks like right now. So let's see. And here it is. So it's basically the ID plus this hash symbol. And so we want to basically remove this first character. Or in other words, we only want to start reading from the string basically at the first position. So we can do that easily using the slice method starting at 1 all the way to the end. And so now, instead of having the ID hard-coded here, like we have right now, we can simply insert the ID right there. So, ID. And so let's now check. Okay. And now it's Jay's signature pizza crust. And if you go here, then it's the spicy chicken. And as we click here, then again it changes. And you see that the ID that we get here of this recipe object is indeed exactly this one here that is coming from the URL bar. Great. So this was actually already a pretty important part of our application's functionality. But now what happens if we take this entire URL and copy it and want to open it in another tab? Well, then no recipe at all shows up. And so that's because this time the hash did not really change, right? We simply opened this page here, but we never changed the hash. And so we also want to listen for the load event. So basically for the event of the entire page loading. Okay, and that's easy enough. So all we would have to do is duplicate this and listen for the load event. So this event here is fired off immediately after the page has completed loading. But here we have some duplicate code. And so I actually wanted to show you a nice way in which we can do all of this at the same time. And imagine you had like 10 events for which you wanted to run the same event handler function. So then it wouldn't be good to have this same code here 10 times, right? And so instead, what we can do is a nice array which contains these two events. So hash change and load. And then we can simply loop over this array and do something. And so for that, we use for each. And in this array, each element is an event. So E for event. And then here all we have to do is window.addEventListener, and then the event, let's call it EV, because usually the E is the actual event object. So let's not get confused here. So the event, and then the handler function. Okay, so this is now exactly the same as having these two lines here. So in the first iteration, this EV will be hash change, and in the second, it will be load. Right? Let's just comment this part out. And, well, let's copy this again, close it, and open. And indeed, now it loaded the recipe right at the beginning. Okay? And now just one more scenario. Let's say we didn't have any hash. Well, then we get an error, right? So something went wrong, and then our spinner here keeps loading forever. And so the problem is that right now we don't have any ID, right? So right here, we are trying to read the ID, but then the location doesn't have any hash. And so therefore, maybe you saw it here, we have an empty string, basically. And so then we are trying to find a recipe for the empty string. And so, of course, then we get an error. And that error will then trigger the alert window that we saw. And so let's put a simple guard clause right here, saying that if there is no ID, then return. And that's it. And again, using guard clauses like this is really the modern way of performing this test. So the old way would have been to write if ID, and then we would have to wrap all of this code here into the if block. And so that would then create unnecessary nesting and make our code harder to read. So if we save it now and reload it now, well, then we don't get any error and everything works fine. And so we can now safely click here, and then each of these different links will load these different recipes. All right. And that's actually it for the very core functionality here that we have in our flowchart. So at least of this right side of the flowchart. So this is now basically implemented at this point. However, it is not implemented in a very clean way. And so in the next lecture, it is finally time to talk a little bit about the architecture that we're going to implement in this project. So we already implemented a part of the Forkify application, but at this point, it has no structure whatsoever. And so now it's time to talk about the project's architecture, but also about software architecture more in general. Now, we touched on this already in the mapd application a little bit earlier, but in this lecture, let's now go a little bit deeper. And first of all, why do we even need an architecture when we build software? Well, there are actually multiple reasons. First, the architecture will give our project the structure in which we can then write the code. So just like a house, software also needs a structure. Now, in software, structure basically means how we organize and divide the code into different modules, classes, and functions. So all these will basically hold our code together and give it structure. The next reason is maintainability. So when we build a project, we always need to think about the future and keep in mind that the project is never really done. It is never finished. We will always need to change things in the future, and we will need to maintain the project. And that only works if the project is nicely structured. Plus, we might even want to add new features to the project, which brings us to expandability. So expandability is basically the ability to easily add new features in the future. And once again, that is only possible with a good structure and a good overall architecture. So the perfect architecture is basically one that allows for all these three aspects of structure, maintainability, and expandability. Now, in order to achieve that perfect architecture, we can of course create our own architecture from scratch. And that's exactly what we did in the Mapd project. However, that only works with a really small project like that one. But when the project grows more complex, then it's going to be very hard to achieve a good architecture completely on our own. And so instead, we can opt for a well-established architecture pattern that developers have been using for years or even for decades. And examples of that are Model View Controller, Model View Presenter, Flux, and many other architectures. And so that is actually what we're going to do in the Forkify project, because it's a bit more complex than the Mapd project. Now, these days, in modern web development, many developers actually use a framework like React, Angular, Vue, or Svelte to take care of the architecture for them. And so in this case, developers don't have to think a lot about architectures on their own. And probably this is actually a good idea at a certain point, especially for large-scale applications. However, and this is key, as I said many times before, it is very important that you really know JavaScript before switching to some of these frameworks. And in my opinion, that includes knowing how to implement an architecture by yourself. And so that's what I will teach you with this project, among many other things, of course. And so this will make it then so much easier for you to learn React or Vue or whatever framework that you choose later down the road. Now, no matter where the architecture comes from and who develops it, there are some components that any architecture must have. And that is business logic, state, an HTTP library, application logic, and presentation logic. So business logic is basically all the code that solves the actual business problem. So that's code that is directly related to what the business does and to what it needs. So if your business is what's up, then your business logic will include sending messages. Now, if your business is a bank, then one of the many parts of business logic will be to store transactions. But if your business is a budget manager, then your business logic will certainly include calculating taxes. So you get the point, right? So essentially, business logic is the logic that is really related to solve the problem that the business set out to solve in the first place. Okay, next is the state, which is one of the most important aspects of any web application. So the application state is essentially what stores all the data about the application that is running in the browser. So the data about the application's front end, basically. So the state should store any data that you might fetch from an API, or data that the user inputs, or what page the user is currently viewing, and so on. And this data should be the so-called single source of truth, which should be kept in sync with the user interface. So that means that if some data changes in the state, then the user interface should reflect that. And the same is true the other way around. So if something changes in the UI, then the state should also change. Now, storing and displaying data and keeping everything in sync is one of the most difficult tasks when building web applications. And that's why there are actually many state management libraries like Redux or MobX. But in this project, we will keep things very simple and use a simple object to store our entire state. Next, the HTTP library is simply responsible for making and receiving AJAX requests. And we have been doing that using the fetch function, And so that's what we will keep doing here. And most real-world applications, of course, need some interaction with the web, and so that's why this is an aspect to keep in mind. Now, about the presentation logic, this is the code that is only concerned about the implementation of the application itself. So it's more the technical aspects of the application which are not directly related to the underlying business problem. So, for example, application logic includes handling of UI events and navigation on the page. That's the reason why this component is many times also called a router. So basically mapping actions to the user's navigation. Finally, the presentation logic, which is also called the UI layer, is of course all about the visible part of the application. So essentially, we can say that the presentation logic is responsible for displaying the application state on the user interface in order to keep everything in sync. All right, now any good architecture has a way of separating all these components. So instead of mixing everything together in one big file and in one big mess. And so let's now take a look at a well-established architecture pattern that we're going to use in this project. And that is the model view controller architecture. So basically, this architecture contains three big parts, which are the model, the view, and the controller. Now, the view is of course for the presentation logic, so it's the part of the application interacting with the user. The model is all about the application's data, and so that's why it usually contains the state and also the business logic that manipulates the state. So these two should be kept closely together. Now, the model is also what contains the HTTP library that might get some data from the web, so like from some API or some backend. And so this is of course also about the data, and so it also goes into the model. Finally, the controller is what contains the application logic, and it kind of sits between the model and the view. So it basically creates a bridge between the model and the view, which in fact should know nothing about each other. So again, the model and the view will exist completely independent from one another, and not even knowing that the other one exists, basically. And in fact, one of the big goals of the MVC pattern, so of this model view controller architecture, is to actually separate business logic from application logic, which makes developing the application so much easier. But as a consequence, we then need something to connect these two parts, and so that is the controller. All right, and now let's actually take a look at a typical flow of actions and of data as soon as some event happens on the user interface, for example, like a click. So to start, it's gonna be the controller who will handle that event, because handling an event is doing something in the application, and that is clearly part of the application logic. Now, this handling might involve updating the user interface and also ask the model for some data. So we can say that the controller dispatches tasks to model and to the view. Or in other words, it controls and orchestrates this entire action, and in fact, the whole application itself. Now, asking the model for some data might of course involve doing an AJAX request to the web. And so that's exactly what the model does. Then, when the data arrives, the controller takes the data and sends it to the view. And so finally, to finish, the view will render that data to the user interface and finish this whole cycle. Now, in this diagram, you see two types of arrows, right? So the dotted arrows represent data flow between the different parts, while the solid arrows represent actual function calls and module imports. So analyzing this, we can see that it's only the controller who imports and calls functions from the model and from the view, but never the other way around. And so, as I mentioned before, the model and the view are in fact completely standalone and completely isolated. All right? So again, they don't import each other, and they don't even import the controller. And in fact, they don't even know that the controller exists. All they do is to basically just sit there waiting to get some instructions from the controller. Okay? And this part is pretty important to understand, so take some time to really analyze this. Now, there are actually different ways of implementing the MVC pattern, where some are more complex than others, but this one is my favorite way of doing it, because I think it makes the most sense. But anyway, let's now see this MVC architecture applied to the part of the Forkify application that we already implemented. And so this is a flowchart of loading and rendering a recipe that we already implemented. And then down there's also a reminder of the MVC diagram that we just analyzed. So in this flowchart, handling these events is associated to the controller, right? Then loading the recipe happens in the model. So the controller basically calls some function that is in the model, and then the model asynchronously gets the recipe data from the API. And once that data has arrived, the controller asks for that data, receives it, sends it to the view, which will then ultimately render the recipe on the screen. And that's it. So that's what every step of the flowchart is associated to in the MVC architecture. But this is still quite abstract because remember, the flowchart is simply what we will implement, not how we will do that. And so let's go even deeper and actually take a look at a detailed implementation diagram of our MVC architecture. And again, this is only about loading and rendering a recipe. And let's start by noticing how both the model and the controller are implemented in a module, while the recipe view is actually a class. And we will explore the reasons for this when we actually write the code. But now, once again, let's analyze the same data and actions flow, but this time in this real implementation. So when the user clicks on a search result, there is a control recipes function in the controller, and this is the one that will handle this event. And how exactly that happens doesn't matter for now, so we will come back to this later. What matters is that this controller will instruct the recipe view to render a loading spinner while the user interface waits for the data to arrive. In the meantime, the controller also calls the load recipes function in the model to fetch the recipe data from the Forkify API. Now the model also contains a big state object that we export from the model. And this state will contain all sorts of data, like the current recipe, search results, bookmarks, etc. But anyway, as the data arrives, it will be stored in this state object. And the controller then reaches into the state object, grabs the recipe data, and finally calls the render method on the recipe view with that data. So in order to finally render the recipe to the user interface. So basically the exact same steps as before, but this time actually implemented in our code. Well, at least in theory. And so next up, let's actually go from theory to practice and implement this architecture in our code. Welcome back. So now that you know everything about the model view controller architecture and also how it's going to be implemented in our project, let's now actually go do that in practice. And this is going to be a long lecture, so let's get started. And let's start by creating the necessary new files so that we can then split up our code between them. So let's start by closing all of the folders here. And then inside of stores and JavaScript, let's create a new file, which will be called model.js. And so this is basically going to be the module in which we write our entire model. Then we also need the view, or actually the views, because we will have multiple views, basically one for each feature. So now we're working on displaying the recipe, and so this one is going to be called recipe view. But actually, let's create a new folder here for the views in order not to clutter our JavaScript folder. All right. And so then in here, let's create recipe view.js. So we will have one big module here for all the controllers, then one big file for the entire model. So for all the models, basically. So for the recipe, for search, for bookmarks, and all of that. But for the views, we will have one module for each of the different views. And you'll understand why that makes sense as we keep developing our application. And probably the first reason that comes to mind is that the views are simply much bigger. And so we don't want a file with like 500 lines of code. We could, of course, also split up the model and the controller, and probably many people would do that, but I don't want to have to mess with a lot of files here in this project. That would just make it very confusing for you to follow. So let's actually take a look again here at this architecture that I showed you in the last video. And here we will actually start with the model. So again, we're going to have a big state object, which then inside will contain an object for recipe, search, and bookmarks. And now we will just start with the recipe. And then there will be a function for loading the recipe, right? So that function will then be called by control recipes, which kind of sits between loading the recipe and then rendering it using the view. So remember that the controller kind of sits between model and the view, so it acts like a bridge. All right, and let's actually keep it open here and close all of these others. And so here in our model, let's simply create that state object. And then in there, we have the recipe, which in turn is also an empty object, at least at the beginning. And then we will export this state so that we can then use it in the controller. And let's put them here just like in the diagram, model, controller, and view. Okay, so we're exporting the state from here. And now let's also create that load recipe function. And of course, we also export it so that we can use it in the controller. So load recipe. And this function will be the one responsible for actually fetching the recipe data from our Forkify API. And so this is going to be an async function. All right. And so now we can actually start grabbing some of the code from here. Okay. So as I said, basically the goal of this lecture is to refactor all the code here into the different parts of the architecture. Okay. So what here exactly is concerned with basically getting the data? So it starts here when we fetch the recipe from the API, and then basically it's all of this here. So all of this. So let's copy it. So rendering the spinner, of course, has nothing to do with the business logic, but really it is only presentation logic. And so this one will eventually go into the view. And then here getting the ID, this is also not business logic. This is actually more about the application logic itself. So about making the application work. And so let's keep that part here. And so again, I will just copy this or actually cut, and put it here. Now we start getting these errors, but never mind. Probably we should actually terminate our process here with Control-C so that we don't get errors all the time. Okay, now we need to, of course, adjust this here a little bit. So this first part here makes sense, right? Now we just need to get this ID from anywhere. So right now we have no idea which ID we should actually fetch. And so it's probably a good idea to pass that ID into this function. So the controller is the one that will actually get that ID right here. And so then when it calls the model, so the load recipe function, it can pass that ID into it. Then this part here can all stay the same, and this as well. And this actually should now not be the recipe, but state.recipe. And here we can just create a const from this. And here let's then also log state.recipe. All right. So this function here is not going to return anything. All it will do is to change our state object. So this big state object, which will then contain the recipe, and into which the controller will then grab and take the recipe out of there. And this is going to work because there is a live connection between the exports and the imports. Remember that? So when this state object here is going to get updated by load recipe, then that state is also updated in the controller, which imports the state. So let's now actually import all of that into here. So doing it here at the very top. So import, and then from the model, we simply want to import everything. So we have a couple of named exports here. So again, there are named exports and default exports, and these ones are named exports because we explicitly gave them a name. And so here we can simply import everything and then call it the model. And so here in the controller, we will then end up with model.state and model.loadRecipe. Remember that? And then here, the current folder model.js. Okay. So let's go back here to loading the recipe, and the spinner should probably be outside of here. And so here, now let's actually call the function. So let's call model.loadRecipe and then pass in the ID. And this loadRecipe function is an async function. And so therefore, it is going to return a promise. Remember? And so therefore, here we have to await that promise before we can move on in the next step here in the execution of this async function. And so you see, this is exactly the situation of one async function calling another async function that we already studied in one of the previous sections. Remember that? And so again, it is really, really important to keep in mind that an async function will return a promise that we then need to handle whenever we call that async function. At least if we want to get some result out of it, or if we kind of want to stop the execution in the function that is calling the other async function. All right. So again, really important to understand the mechanics of what is happening here. Now here we should probably also have some error handling. So I forgot that part. So try on all the way down here, and then catch the error, and then alert the error as well. All right. So remember that this load recipe function here does not return anything. And so therefore, we are not storing any result into any new variable. Instead, here we will get access to state.recipe. So to that state.recipe that is going to be manipulated right here. So you see that this load recipe function here clearly is not a pure function. So it has the side effect of manipulating this variable that is outside of it. And there would be different ways of avoiding that, but that is just a lot of work and it's just not worth it here in this case. We are still trying to learn here, remember. But anyway, we now here have access to model.state.recipe. And so just in order to see if everything still works, let's store that recipe into the recipe variable so that we can then render it using this code that we already have here. So just temporarily recipe and then destructure it. So let's give it a save and let's restart our application here. All right. Let's reload here and you see that it's working. Right? So everything we implemented so far was correct. And that's pretty important to keep checking when we are refactoring code like this. Okay. So that was actually the easy part. Now comes the recipe view, which will then contain basically all the rest of the code that we have here. So let's go here and set the view up. So the view is going to be a class, and in this case called recipe view. And we do this because later we will also have a parent class called view, which will contain a couple of methods that all the views should inherit. And so using classes makes all of this very simple to implement. Also, we want each view to have a couple of private methods and properties. And so classes makes this really easy to implement again. And just in general, I feel that classes are really the right way to go here. And again, it will make even more sense once we start to add the parent class of view. But anyway, I mentioned that I want each of these classes to have a couple of private properties. And one of them is going to be the parent element. So parent element, and let's right away set the parent element to the recipe container. So basically to this element, all right? Because this will then make it really easy to render the spinner and to render success or error messages, or to render, of course, the recipe itself. So if each of the views has this parent element property, then it will be really easy to do all of those tasks. And again, that will become really clear once we start adding more and more views. But now the next thing I want to do is to actually export something from this module. So of course, we have to export something from this view so that the controller can then use it. Now, what are we going to export from this view? So we might export, of course, the entire class like this. And so then here in the controller, we would have to import that class and create a new object out of that class. So basically create a new recipe view object, right? However, in that situation, it might be possible to create more than one view, and we would never want that. Also, that would add unnecessary work to the controller, which we basically want to keep as simple as possible. And so in order to avoid all that, we will already create the object here and then export that object. And so like this, no one from the outside of this class here will have access to anything except for the object. So what we will do is to export default and then a new recipe view. All right, and that's actually it. So we don't pass any data in, and so therefore we don't need any constructor even. Okay, and then here all we do is import, and here we then can give it any name. So I'm calling it recipe view because I think that's what makes most sense. And then views and then recipe view.js. Now, how do we then actually pass any data into the recipe view? Because if we're not creating the new object ourselves, then we cannot pass any data in, like for the constructor, right? So we cannot pass any data into this recipe view, well, because we're creating that object right here in the recipe view module already. But actually, I did that on purpose so that we can create a very nice method called render. So what I will want to do here, and let me already write it here, even before having the method. So what I will want to do is to call recipe view.render. And then here, all we do is to pass in the data, which will be model.state.recipe. And this method here called render is a very common name for methods. For example, in React, it is also called render. And so I think this is a nice name. It's really descriptive of what is going to happen. All right. So if we did export the entire class, then here we would have to do like const recipe view equal new recipe view or something like that. And then here we would have to pass in the data like this when we create the new recipe. And of course, this would also be possible, but honestly, I like it better like this. So having this nice render method is a lot more descriptive and a lot cleaner, and also for the reasons that I explained previously already. Now, anyway, this render method here will now accept this data and will then store it into the object. So let's add the public render method. So this is, of course, part of the public API. So this receives data and will then set this dot data to the data it just received. So we need to declare that up here. And so this render method here and these two properties are something that all the views are going to have in common. And this will be really beautiful to work with, as you will see. But now let's actually do something with this data, which is to actually render it. So basically what we want now is to take all of this code and cut it from here and put it into our view. Okay. Now we will actually not put it into the render method because again, this method will later be common to all the views, so to all the classes. However, each view will of course render a different HTML. And so we will simply have a method that generates that HTML so that the render method can then render that HTML. So if that sounds confusing, let me write it in code. So generate markup. And so this is going to be a private method. And since we're using Babel here, I can already use this syntax here. So pasting the code here. And so this is going to generate this markup variable, and we can actually immediately return that from here. Okay. Now, this is not going to do anything yet, because what is recipe here in this case? It's nothing, right? It's not defined at all. Now, in this case, where is this data actually? Well, it is in this .data, right? So why is that? So let's take a look at our controller, and let's start from the beginning. So the recipe is loaded here, and then that will store it into the state object, right? Here we don't need that anymore. Then here we take model.state.recipe, which is that data that we just received here in step 1, And then that data is passed into the render method, right? And so render method then takes that data and stores it inside of this .data. And so this is so that we can then use that data all over the place inside of this object. And by the way, this is exactly what we have here in this architecture diagram. So inside of control recipes, the load recipe function is called, then the recipe data goes into the state, and then that data passes right through the controller basically and goes into the render method, which then in turn calls generate markup. So you see, we already have many things here implemented already, like data and parent element. We're just missing some small parts, but we are going to get there. But now what we were doing here is to discuss where this recipe data is actually located right now. And we came to the conclusion that it is in this .data. So I will copy it, and then we need to replace all the recipe dot here with that. So I'm hitting Command D. So for you that should be Control D. And then let me paste that dot, and then that's it. All right. Then down here we have this code, which is not supposed to be here, because all this function does is to return an HTML string. And it's going to be the render method that will be responsible for then actually putting that HTML onto the page. Okay. So here, let's say that the markup is this dot, so generate markup. Well, this is probably something that's coming from Babel here. Not really sure why, but apparently VS Code doesn't like this yet. We're still missing the dot here, of course. And now it appears to be working. And of course, we still get some errors here, but never mind about that. We are still refactoring. So we have our markup. Now we need to put it on the page. So again, we need to start by clearing the parent element. And actually, let's create another small method for that. So just to get in the habit of abstracting some code. And so now this is where our parent element will come into play. Because now we can say this dot parent element dot inner HTML and set it to empty, right? And so this method here will be usable for all the views as long as all the views have a parent element property like this one, right? So all of this will become really reusable, as you will see in one of the future lectures. So here we now can then call that. And then to finish, we can finally render that HTML to the page. And so here, once again, we can now use this dot parent element and then insert that HTML there. Okay, so this might already be working, actually. So all of this here looks good to me. Let's take a look at the controller. And you see that this is now a really nice and small function here already, right? Now this one, we actually want to call it control recipes. So let's replace it everywhere. Control recipes. So that's the name that I have here in the diagram. Okay. And so now what we're missing is only to export the render spinner also into the view. So this one, of course, also has nothing to do with the controller, and so it belongs in the view. So of course not a function, but a method. And this one will also be a public method, so that the controller can then call this method here as it starts fetching the data. Okay? And now here again, we have the beauty of the parent element already being inside of the object. So this one we can simply delete, and here we can replace it with this dot parent element. All right. Next up, I'm seeing that this icons variable is not going to be defined anywhere in this module. So we will need to grab that from here. So you see that here we have the icons, and we don't need them here anymore, at least. So now we need them right here. And now what we need to do is to then call this render spinner method right here. So that's going to be recipe view dot render spinner. And here again, we no longer need to pass in the parent element. And just watch how beautiful this is. So we have recipe view and then render spinner. And we already know that this will then automatically render the spinner on the recipe view. And the same is later going to happen with other views. For example, with the bookmarks view. We will also have a render spinner on the bookmarks view, and it's going to work the exact same way. And the same with render. So all we have to do is to call these same methods then on all the views, and they will then simply act on whatever view that we are calling them. Right? And that works so nice because we have this parent element here and also this data property. So I think that this is a really nice architecture. And so let's now actually see if this works. So let's reload this here. And here we have some errors. So apparently if there is a really big error, then Parcel will let us know about that. And in this case, the problem is that it failed to resolve this URL. And that actually makes sense because this view here is in a different folder, right? So here we are only going one folder up, and going up one folder from here will end up in the JavaScript folder. However, we want to go into images. So we need to go up one more level. So like this. Okay, so here we have apparently some bug. Let's just see if anything happens still on this event, and it does. There's still some problem here. Maybe that has to do with the fact that we are using these private methods here. So let me change this here to this one. So right here, yeah. And let's also comment out this one, and then we're not using any private methods anymore. However, that is apparently still not working. All right, so let's take a look here at our this.data. So this.data, just to see what we get here. And so we see that apparently that method is not even being called. And I see the problem. I actually did not call it. So I didn't use the parentheses, right? So what a stupid mistake. So let's roll back on all the changes I did, except of course for this one. But here, probably all I need to do is to call these two methods. Beautiful. So we're back. It's working now again, and it's working really nice, including the spinner. Okay. And so I think with this, we successfully refactored our entire code to this new architecture. Well, not the entire code, actually. We're still missing this handler here and all of this part that is here, but don't worry about that for now. Okay? We will have a separate lecture which will talk about how we can handle events in this particular architecture. For now, what matters is that this works just nicely. There's just one thing that I actually want to change, but that has nothing to do with the architecture. So what I want to change is these numbers. So do you see here we have 0.5, but in the real world, you will see this more like this. So like 1/2 tablespoon of brown sugar instead of 0.5. So this looks a lot nicer, or this, for example, 1.5 is a lot nicer than 1.5. And so for that, we are actually going to use an external library which will very easily do this for us. Okay? And so I included this part so I could show you just how to do this. So let me just Google it here, npm fractional, just so we can see what this package looks like. So if you Google npm, then you will usually end up on npmjs.com, and this will then contain like one page for each package that is on npm. All right. And so here what you see is that you can basically create new fractions based on numbers, and then you can do all kinds of multiplications with them, like multiplying, dividing, and in the end converting them to a string. And so that's what we will do now. So we will convert each number to a fraction and then immediately convert them to a string. So this is how we install it. Let's just grab that. And then we need our terminal back. Let's add another one. So that's the plus sign. And this should be pretty fast, hopefully. And so we need that here. So let's import fractional from, and then fractional. And so here again, you see that any libraries or any packages that we import from npm, we don't even have to specify any path. All we have to do is to write their names here. And then here we need also what they export. And let me see what they actually export. So it should be called fraction. Okay. So this library actually exports something called fraction. And we can see that because here it is importing the fractional library using require. And that is simply the old CommonJS way of importing, which I showed you earlier. And so that is one of the reasons why I showed that to you, because, yeah, again, you will see this all the time in the wild still, because so many packages on npm are still using CommonJS. So let's import fraction here, actually like this. Okay, let's just see if this actually does exist now. And yeah, it does. So actually that's even fraction inside of fraction. But anyway, let's now go ahead and use this actually. So that is in here. So here we now no longer simply want the quantity, but we want the quantity converted to a fraction string. So according to the documentation, we have to say new fraction, and in this case, it's actually fraction dot fraction. So again, that's because here inside of fraction is where the fraction function is actually located. Okay, and here you could see that we have to then use new. Now, actually, to make this a bit nicer, we can also use destructuring here right away. So we can do this. And if we now take a look, well, now we have this bug here, but never mind. So let's just do this and then call toString on that, just like it said in the documentation. So you see that now as I destructured that fraction, it became the actual function. And yeah, here you see beautifully that it is now in this size or in this format of the fraction. And if I take a look at the other one, then the same as well. Now, this one doesn't look very beautiful, but never mind. So we cannot fix all of it, but at least this looks really cool now, right? And so this is when we reach for packages on npm. So when we need some functionality that we don't want to implement ourselves. I'm just going back here because I noticed some problem here, which was this one. And that was because previously here we had null. So there was no value for this cilantro. And so here we should probably check if the number does exist. So we can say inc.quantity. If it exists, then do this. And if not, then simply put an empty string there. And of course not here. So that must be out here. Yep, now it's gone and it looks a lot nicer. All right. Now just to finish, I actually want to refactor this function here. So let me grab this and put it down here and call it generate markup ingredients, or just ingredient. Okay, and this will then receive the ingredient. Okay, and then here inside of the map, we can then simply call this dot, and let's copy it because these private methods, for some reason, VS Code doesn't really understand them yet. So right here, and so successfully refactored this part. And so we are now done in this lecture where we also successfully refactored the entire code that we already had to the model view controller architecture. All right. So we're not done 100%, but we've done a lot of work in this lecture. And I really hope that you understood everything that we did here. So this was a really, really, really important lecture. So make sure that you understand everything that we did. So make sure to review all the code and also compare it here with this diagram one more time so that you see which functions we call when, and then also how exactly the data flows between these different functions, and especially here in this view, because I know that this can get a little bit confusing. And so reviewing this is going to be a very good idea, especially because we will use this so many times also in the other features. And so by then, you really must understand how all of this fits together, because otherwise it's going to be very hard to follow the rest of the project. Okay, so take your time and only then move on to the next video. Many real-world applications have two special modules that are completely independent of the rest of the architecture. And these are a module for the project configuration and also a module for some general helper functions that are going to be useful across the entire project. And so let's now implement these modules in our own project. And let's start with the configuration module. So let's maybe close this one here first. And then in our JS folder, we create a new file, config.js. Okay. And so here into this file, we will basically put all the variables that should be constants and should be reused across the project. And the goal of having this file with all these variables is that it will allow us to easily configure our project by simply changing some of the data that is here in this configuration file. So therefore the name of config. So of course, we will not want to put all the variables here in this file. The only variables that we do want here are the ones that are responsible for kind of defining some important data about the application itself. So one example of that is, for example, the API URL. All right, so this URL here, we will actually reuse in multiple places across this project. For example, for getting search data and also for uploading a recipe to the server. And so all of them will use this URL. But then imagine that at some point the URL needs to change. For example, because there might be a version 3 at some point. And so as always, we don't want to change that everywhere and simply have a variable which contains this, which we can then reuse. So let's cut this here. And you might argue that we can also simply create a variable here in the model, but then we would have all these configuration variables spread across multiple modules. But it's way easier to simply have all of those variables in one central place. And so that's what we're going to do here. So let's call this one API URL, and then paste that here. Okay, and now all we have to do is to export this constant from here. So I'm using uppercase here because this is basically a constant that will never change. And so using uppercase for that kind of variable is kind of a common practice, especially in a configuration file like this. So API URL is one of the variables that makes a lot of sense. And let's actually go to our documentation page, because indeed, as I mentioned before, we are going to use this URL for this and also for getting recipes. So then we will simply have to add the /id. Another great candidate for being a configuration variable is going to be this API key that we will generate a bit later. So let's leave that for now and go back here to this API URL and now actually import that here into the model. So import, and now remember that here we have a named import. And later we will actually also have more named imports. Okay, and so here I could go ahead and import all of them basically at the same time and then as config. But actually I prefer to import them one by one, basically with their actual name. And so remember, we do that by using curly braces and then the name of the variable like this. And then config is in the same folder. And so that should work. And here, all we have to do now is to replace, or to actually put, that API URL right here. So if we save this now, then our application, well, let's see. And yeah, it is back to working, right? And so we successfully basically exported this configuration value that we had here into this config file. Okay, next up, let's create a new file for some helper functions. So this one is usually called helpers.js, and the goal of this file or of this module is to contain a couple of functions that we reuse over and over in our project. And so here in this module, we then have a central place for all of them, basically. And to start, one great candidate is to actually create a function which will get JSON. So basically a function which encapsulates all of this and also some of the error handling. All right, so let's actually get all of this code and go here into the helpers. And so here let's create a function and export it called getJSON. And so this function is going to be very similar to what we did in the async JavaScript section. So it's going to be an async function which will basically do the fetching and also converting to JSON all in one step. And so with this, we abstract all this functionality into one nice function that we can then use all over our project. And probably we will just use this actually in our model, in this case, but it's still good to have this function in this kind of central place. Okay, so anyway, this getJSON function will take a URL, and so of course this is then what we fetch here. Right, and so with this we can then reuse this function here for all kinds of URLs. Now this here actually already makes sense, and this one here as well. So let's now put all of this into a try block and then catch the error here. Now, what are we going to do with the error here? Of course, we could log it or alert it, as always, to the console, but let's say we actually want to handle that error here in this function. So right here, where we will actually use the getJSON method. And actually, let's do that right away. So import that first, of course. So import, and again, we are using named imports, and I simply want to import the exact variable name. So that's getJSON from helpers, and it's not appearing here, and I just noticed that helpers is actually in the wrong folder. So I put it in the views folder, but it's supposed to be in the JS folder. Okay, and so let's now actually use getJSON here and then think about the error handling that we were just talking about previously. So here, let's say const data will be await getJSON, and then with this same URL here. Okay, and so again, this is exactly what we had done before. There's just one thing missing here. Now we get these errors, which is really annoying. But anyway, there's actually still something missing here, which is to then actually return the data from this function, right? So we didn't do that yet. And so of course we want to return the data. And now, just as we did also in the last video, we have one async function here. So the load recipe function calling another async function, which is this getJSON function. Now this function returns this data variable, and so therefore this data is going to be the resolved value of the promise that the getJSON function returns. And if that still sounds super confusing, then you might just revisit that lecture in the asynchronous JavaScript section. But anyway, what you need to keep in mind is that here this data will become the resolved value of this promise. And so here, that's why we then await that promise and store that resolved value into the data variable. And so then the rest here is going to work in the same way. But now back to error handling. And let's say here we want to actually not alert, but to log that error to the console. Let's say console.error, and then here the error. And let's say we want to do it in a special way, just so we see which errors are our own. So using some emoji here to make it really visible. So this is here our temporary error handling, which we will improve dramatically in one of the next lectures. But anyway, the point that I'm trying to make is that the error is actually occurring here, right? It is going to occur in the getJSON function and not here. Remember that? So when there's going to be an error here in this function, then the promise that the getJSON function returns is actually still being fulfilled. So it's still basically a successful promise, even if there happened an error here. And so let me show that to you actually. So now everything works just fine. But let's now use some invalid URL here. Then we get some error here, but that's not the one we are interested in. So the actual error is this one here, And it's coming now from helpers.js at line 5, or actually line 11. So this is the error that we're logging right here. So this one here, right? So we're logging it to the console here, right in the helpers function. However, this is actually not where we want to handle that error. We really would like to handle it right here in model.js. So basically, instead of this error message here, which is simply a consequence of this first error, we would like to get this error message inside of the model, right? So do you remember how we do that? Well, we have to rethrow the error. So we have to again use throw and then simply take the error object that we already have and simply throw this new error. And so now with this, the promise that's being returned from getJSON will actually reject. Okay, and so then we will be able to actually handle the error right here. So let's try that again. And indeed, now we get that same error message that we had before right here in the model as we wanted. Okay, so we basically propagated the error down from one async function to the other by rethrowing the error here in this catch block. And that's really important to do, and we will actually come back to this in one of the future lectures. Okay, and now to finish, let's make this function here a little bit more robust and more real world by adding some timeout. So basically setting a time after which we make the request fail. And so this is important in order to prevent for really bad internet connections where then this fetch here could be running forever. And we actually already did that previously in the async JavaScript section. And so here in the controller starter code, I had already this timeout function. So we don't have to code it all over again. And so let's put that here. And so basically what this function does is that it will return a new promise. So this promise here, which will reject after a certain number of seconds. And so in order to now use this function here, we will have a race between this timeout promise, which will take whatever seconds we pass into it, and this fetch function here, which is the one responsible for getting the data. And then whatever occurs first will win the race. So let me just put that in code actually. So remember that works by using promise.race, and this takes in two promises. So the first promise is this one, and then the second promise will be timeout with a certain number of seconds. And here for now, let's just say 10 seconds. Or actually, let's just say 0.5 seconds so that we can actually test this. So here we're still getting some errors from somewhere in our code because of this error. But never mind. Oh, and now Google Chrome crashed. And here we are back. So let's just again click somewhere here. Now we still get this weird error. So let's actually check out what's happening here with cannot read property JSON of undefined. Well, maybe it's already because of this timeout here. So let's try to put it to like 5 seconds. Let's try it again. But it's got to be something else. So it seems like there is some problem somewhere here. So here, for some reason, is this parenthesis, which doesn't make any sense. But it is VS Code, which for some reason puts it there for us. But this parenthesis doesn't make any sense because now this looks like just one element of this array. So let's just create this promise outside. So fetch promise is going to be this. And so hopefully that will fix it. Well, it doesn't. Oh, but I see what's the problem. I'm actually not even calling promise.raise. I only put the brackets there. So that was probably the reason. And so now it should work indeed. And so if we reload this, then yeah, it works. So now we can actually test what's happening here with the time. So setting it to half a second. And so that still works. And so let's make our network a little bit slower. So a slow 3G. And this should then take some time. And so let's see if we can now time out the request. So let's wait for it. And indeed, now the request took too long, timeout after half a second. Okay, so let's analyze what happened here. So we passed in half a second here, and so after that time has passed, this promise simply rejected with this error message. And so as soon as any of these promises here in the race rejects or fulfills, then that promise will become the winner. And so therefore, we now have a rejected promise here, which will then trigger the catch block here. And so that error will then be thrown again here, and then it will make its way here into the load recipe function, and eventually will be handled down here. And so that's why we get these 4 explosions down here in the error message. All right. Now, of course, then in the real world, we will want to do something with that error. But again, a bit more on actual error handling a bit later in the section. For now, let's set a more realistic value here. So of course, we don't want to time out after just half a second. Let's say like 10 seconds. Now, in fact, this is one of these so-called magic numbers or magic values, which is like a value that seems to appear out of nowhere. So if someone reads this code, they will find this number 10 and not really understand what it's doing. And so one more time, this is a perfect candidate for a configuration value. So this is really something that we might want to change about our application. And so then if we want to do that, all we have to do is to come to our config file and change that here. So let's call this one timeout seconds and set it to 10. Okay. Then here we can import that. So again is a named import. And so here we use the curly braces. So timeout seconds from helpers.js. And this import that is already here was probably put here by a parcel. So I don't remember doing this here. And so it must have been parcel who put this here in order to make the code work. Okay. And so now here we can use the timeout second constant. And so now whoever is going to read this code will see that this is one of the configuration values. So first, because it is in this uppercase, and so that helps already with understanding the code. And then also because now it is a variable. And so it's no longer like a magic number that we don't really understand where it's coming from. Okay, and so that's exactly what this configuration file here is all about. So these are 2 important files that are used in many applications in the real world. And so make sure to also include them in some way in your own applications in the future. Okay? And now in the next video, we will kind of finish this architecture and really implement the missing part here, which is kind of handling the events in a better way. And so let's go do that right now. So let's now learn how we can listen for events and also handle events in our MVC architecture by using something called the publisher-subscriber pattern. And let's start by analyzing the code that we already have here. So right now we are listening for the hash change and for the load events right here in the controller. However, that doesn't make a lot of sense, does it? Because everything that is related to the DOM, so to the view, should really be inside of a view. Now, maybe these two events here don't really look as if they have to do with the view, so with the user interface, but imagine that instead we would be handling a click event on some DOM element. And so listening for that event should for sure go into the view. And therefore we can say the same about these events here. So in the end, this has more to do with DOM manipulation or with the DOM itself than actually with the controller. And so therefore we need a way of putting this logic here into the recipe view. However, the handler function that we use to handle these events is actually this controller. So it's this function that we have up here that is sitting inside of this controller module. And so we have basically a problem here. We don't want this code to be here, so we want it to be in the view. But in this code, we need this controller function, which is here in this module. And of course, we don't want to put this function in the view. And so let's now think about how we could solve this problem. And recapping everything that I just said before, we can basically say that we want to handle events in the controller because otherwise we would have application logic in the view. And of course, we don't want that. But on the other hand, we want to listen for events in the view because otherwise we would need DOM elements in a controller. And we would basically have presentation logic in a controller, which would be wrong in our MVC implementation. So essentially, event listeners should be attached to DOM elements in the view, but the events should then be handled by controller functions that live in the controller module. And so if you take a look at this small diagram that is just a part of the architecture diagram that we already saw before, so here we have the control recipes function in the controller, and we have a special method in the view which is called add_handler_render. Now we might think that it is very easy to connect these two functions. Because why not simply call the control recipes function right from the view whenever an event occurs? Well, that's actually not possible because in the way we set up the architecture, the view does not know anything about the controller. So it doesn't import the controller, and so we can't call any of the functions that are in the controller from the view. So it only works the other way around, and therefore it's more complex than this. But fortunately, there is a good solution. And this solution is called the publisher-subscriber design pattern. And by the way, design patterns in programming are basically just standard solutions to certain kinds of problems. So in the publisher-subscriber pattern, we have a publisher, which is some code that knows when to react. And in this case, that's going to be the add_handler_render function because it will contain the add_event_listener method. And therefore, it will know when to react to the event. Now, on the other hand, we have a subscriber, which is code that actually wants to react. So this is the code that should actually be executed when the event happens. And in this case, that is the control recipes function that we already have in our controller. And remember that the publisher does not know yet that the subscriber even exists, because that subscriber is in the controller that the view cannot access. Okay, but now finally comes the solution to the problem. So the solution is that we can now subscribe to the publisher by passing in the subscriber function as an argument. Now in practice, that means that as soon as the program loads, the init function is called, which in turn immediately calls the add_handler_render function from the view. And that is possible, remember, because the controller does in fact import both the view and the model, right? Now anyway, as we call add_handler_render, we pass in our control recipes function as an argument. So essentially, we subscribe control recipes to add_handler_render. And so at this point, the two functions are basically finally connected. And so now add_handler_render listens for events using the add_event_listener method as always. And then as soon as the event actually happens, the control recipes function will be called as the callback function of add_event_listener. Or, in other words, as soon as the publisher publishes an event, the subscriber will get called. Alright, and this is how we implement event listeners and event handlers in the MVC architecture. So this will allow us to keep the handler in the controller and the listener in the view. And by that, keeping everything nicely separated. So in summary, the handler subscribes to the publisher, which is the listener in this case, and then as the publisher publishes an event, the subscriber is executed. And if you want to think even deeper about this and are really interested in this, then notice how there is actually a profound difference between a certain arbitrary, like function A, simply calling function B directly, and function A receiving function B as an input in order to then call that input function. So this is all about control. In the first scenario, function A is in control. However, in the second scenario, function A has no control. So it simply has to execute whatever function it receives. So if you want, reflect a little bit on that and see that this is exactly what the publisher-subscriber pattern is actually all about. But anyway, leaving that theory aside now, let's go back to our code and implement all of this. And so with everything we just learned about the publisher-subscriber pattern, actually now implementing it should be the easiest part, right? So let's simply grab this code, so cutting it actually, and then here we will create a new method. And let's just put it somewhere, let's say here. And so this will be our add_handler_render method that we just talked about. So add_handler_render, because this is going to be for rendering the recipe right at the beginning, right? And then this method, which remember is the publisher, basically needs to get access to the subscriber. And so that in this case is the handler function. All right. And so then we can simply paste that in here. And then here, of course, we don't know about control recipes, but we know about the handler. And so that's actually it for this function. So of course, it is not a private method because it needs to be part of the public API of this object so that we can then call it in the controller, right? And so let's actually do that now. So we can get rid of this now, and we will want to do this right in the beginning. So let's create an init function here, actually like this. And then we simply call it right at the beginning. So only once. And actually we could simply put all the code also here in the global scope, but I think it's a bit cleaner to have a separate function for this. That's recipe view dot add handler render. And so now we simply pass in control recipes. And that's actually it. With this, we just implemented the publisher-subscriber pattern. For some reason, we're still getting these errors here. Let's get rid of this alert here, actually, and simply do a console.log here. Okay, but now let's go and see if this actually works. We're still having our slow network. Oh, and here we have some problem, apparently, with the timeout. So let's go quickly fix that here in the helpers. So we saw that here it said undefined, like after undefined second. So maybe this variable here doesn't exist. So maybe it's kind of misspelled. So let's see in the config. Well, it looks right. Yeah, it is the same. Well, let's see again. And so this apparently happens immediately for some reason here. So what if we put it back to some normal number? Well, then it works, which is very weird, because this is in fact also 10. So let's see what we get here as we log timeout seconds. Oh, but I'm actually right now seeing the problem. So this is not helpers, it is config. So we are importing ourselves here. So that was the problem. Let's put everything back. And you see that now it is working. Even with the hash change event. And so that means that we did now successfully implement the publisher subscriber pattern. Okay, and so let's quickly recap what exactly is happening here. So we can also take a look at our final diagram here. And here I actually have the event here in the controller, because that is actually where it is handled. And so I think that in this diagram, this makes it a little bit easier to actually understand the flow of the program. So anyway, as we start the program, so then the init function runs, and it will then immediately run add handler render, right? So it is this function here. And it's this function that is actually listening for events right here in the view where it actually makes sense. Now, as we call this method here, so in the controller, we pass in the controller function or the handler function that we want to get executed as soon as the event happens, right? And here we then receive that function as being called handler. And so that's what we then call as soon as the event happens, right? And so again, in our diagram, that's exactly what we have here. So that's why I have this dotted line here, which stands for data flow. So we are passing in the control recipe function as the handler here. And that is the whole reason why the method here is called add handler render. So because we are using it to in fact add a handler function, and in this case, it is for rendering the recipe in the first place. And then later on, we will actually have other add handler methods. Okay, and so it's crucial that you understand this logic here before you can move on any further in this project. But I hope that with all this explanation, this became all really clear and also obvious why we had to do it like this. I mean, of course, we don't really have to do it. So we are, of course, in charge of our own code. But in order to correctly implement the MVC architecture, this is the best way of doing it. And so again, then we can keep everything nicely separated into model, controller, and view without any overlapping responsibilities. All right, so we have all of this structure here now nicely set up. Everything is nicely separated. And so from now on, all we have to do is to basically use this structure to implement all of the missing features of our application. And so, again, really make sure that you understand everything that we did so far, especially regarding the implementation of our architecture. And then, once you are really done with understanding that, let's go straight to the next video. Let's now implement real-world error handling in our application instead of always simply logging errors to the console. And again, the error that we're going to work with is basically using a false ID that cannot be found on the server. So indeed, we get our error message invalid ID and then the ID itself plus the status code. Now, the real-world way of handling an error like this is to actually display some message here in the user interface so that the user can actually know what's going on. So basically, handling the error will mean to display an error message here in the view. So right now, we are handling the error actually in the model, right? So remember how I said that for now, handling the error is simply logging it here with these small emoji here. And so again, that's basically our current error handling strategy. However, it is not correct, and also it doesn't happen in the correct place. Because if we want to display something in the view, then of course that code should also be in the view and not in the model. So let's go back to our code and to our view and implement a new method here, which is going to be responsible for displaying that error message. And actually, the HTML code is already here in this like template. So it's going to be this class here, or this element with the class of error. So let's copy this, go to the view, and then let's put it here after the spinner. So render error, and then like this. And for some reason here I declared like a normal function, which doesn't make a lot of sense. And now let's create a new markup variable as always when we create some new markup, which is exactly what we're doing here. Then here, remember, we need to replace this with the icons variable. And then here, of course, we want to have like some custom message. So we don't simply want this hard-coded message, but instead we want to be able to pass a message into this method. So that's going to be message like this. And so let's add a parameter here for that. Okay. And then here, let's clear the parent element. So like this. And actually, we should do the same here. So this dot clear is a lot nicer than having to write all of this. And so we abstracted all that away into this method. And now we can basically simply get this code because it's going to be the same, right? The variable here is still called markup, and we still want to basically insert this HTML into the parent element. So that's, again, this element with the recipe class. Okay, and so that's actually it here for the view, at least. Okay, so let's now go to the model, because remember that right now we are actually handling the error right here, like this. But again, that's not what we want. So we want a way of getting this error into the view. Now, these two are only connected by the controller. And so, of course, it is going to be the controller who will call recipe view, right? So let's do that actually. So that's going to be right here in the catch block of the control recipes controller. So recipe view dot render error and then some message. But what is this message going to look like? Or in other words, where are we going to get it from? Because now we have the same problem as before. So remember, here in the helpers function, whenever we got this error, then that error was not automatically propagated down to this async function, which was actually calling the getJSON function. And so therefore, we had to rethrow the error here. So basically to mark this whole promise here as rejected, so that then here we would get into this catch block. But now here again, we have the same problem, because now if we get an error here, then this promise, so this whole load recipe promise will also not get rejected. And so therefore, here we will never enter the catch block in this function. So it's a bit confusing, like the flow of the error and how we need to propagate it down. But essentially, we will have to do the same thing as before, which is to throw the error here again. And so with this, we will then have access to the exact same error object as we have here, and otherwise we wouldn't. So now we can use the same thing here. Let's actually get rid of this console.log. And so now here our error handling is basically finally complete. So instead of simply logging it to the console, we now have a way of rendering it to the user interface. And we will be able to access the exact same error that we also got access to here in the load recipe function. Okay, so let's try this. And indeed, here we get the error message, and it is exactly the same one that is logged down here from the model. Okay, however, this is actually not really that useful. So, well, this error is not really meaningful for anyone using this application. And so actually, this is not the message that we want. So let's create a more meaningful message. So something like, we couldn't find that recipe. Now, do you think that we should pass in that message here? So basically specifying we couldn't or we could not find that recipe. Please try another one. So again, do you think that this is the correct place of specifying this message, which will get eventually rendered to the view? Well, actually, I think that it is not. So I think that this error message should basically be an intrinsic property of the view itself. So basically, I'm going to cut this from here now. And now in the view, I will add just another private field. So it's going to be called error message, and then the message itself. And so now, basically, the view itself already knows the message that it wants to display. Okay? And then here, in render error, we will actually keep the ability of passing in a message. But if no message is passed in, then we will simply set a default. And so that default is going to be the error message that we just specified. Okay? So here we don't pass anything now. And so by doing this, we are back to having no code that is regarded to the view here in our controller. All right. And so instead, the error message is then by default set to the message, or actually the other way around. So the message argument is going to be set by default to this error message that we set for this entire object. So I think that is the best solution, which makes the most sense. And so indeed, here we now get exactly that message. And so with this, we now have a very robust and very nice error handling strategy that we will then be able to use for other errors also in the future. So for example, when there are no search results for some search term. Okay. Now, since we did an error message here, let's very quickly also implement a method here for success messages, even though we don't need it yet. but it's still good to already prepare for that in the future. And so since we are working on messages here, let's do that right away. So let's call this one simply render message. And this one here will have a different class. I think it should also be somewhere here. And actually it's this default. So this is actually the one that we will use. So it has the class of message, but then the rest of the code is actually the same. So message, and actually not the same. So the icon is also different. So here it's icon smile. So instead of the alert, it is a smile. And then here we will want some kind of message again. And so here let's now create simply yet another field called message. Could also call it like success message, but let's leave it like this. And for now, we don't have any success message because again, we're not actually going to use this for now. But message, and then the rest should essentially be the same. And then in the future, of course, we will be able to use the success message in some different places in our application. All right, and that's actually it. Let's put it back to some normal URL. We can just click here. And then, of course, everything is back to working. Great. And with this, we are actually finally ready to implement now the searching functionality starting in the next lecture. Let's now start implementing the next feature of our application, which is going to be the search functionality. And let's start by taking a look at our flowchart here. And so again, we already have this part here basically now implemented. And now we are going to work basically first on this part. So handling the event of a user searching for recipes, then loading the search results and rendering them. So that's going to be this lecture and the next one. And then afterwards, we are going to worry about the pagination. So again, we will now focus on these three parts. And so for that, we need to now implement the model, the view, and the controller that binds everything together. And usually I find it easiest to start with the data. So basically with the model, which means in this case, starting to make some API calls in order to load some search results. And then once we have that part working, we can then render them on the screen and also care about the actual event. Okay, so let's actually leave that open here at the end and go to our model here and start implementing the search functionality. So just like before, we are going to create a function that will be exported so that it can be used by the controller. And this one, I'm going to call it load search results. And so since this one will be performing AJAX calls, it's going to be an async function. Now, again, this function here is going to be called by the controller. And so it's going to be the controller who will tell this function what it should actually search for. So basically, it will pass in a query like string, which we can then plug into our API call. All right. And here we are going to need a try catch block. And here in the catch block, all we will do is to basically do the same as here. So all we're really interested in here is to throw the error again so that eventually we will be able to use it in the controller. So just like before in the last lecture where we threw the error here again. So that part is easy, but now let's actually implement the functionality. And to do that, let's go back to our documentations page. And so this is how we get all recipes. So making a GET request to this path, and then with the search parameter, And the way we add a parameter, and I think I explained this before, is with the question mark and then search equal, and then pizza here in our case is actually the search query. And again, for now, don't worry about the key. And we can actually already see what the results will look like here for pizza. And so basically, this is the URL that we need to call in our AJAX request. So let me actually copy it. And let's go back. And so now we can, just like before, use the getJSON method. And so that will then fetch the data and also convert it to JSON and create an error if something went wrong. So getJSON returns a promise, and so we await that here and store it into data, just like always. So getJSON, and then the URL, and we need a template literal. And so, yeah, now we just have to replace everything to make this work. And the first thing is to actually take this here again out and replace it with this API URL that we already have in our configuration file, right? So API URL, and I think that actually already includes the recipes. Yep, so it's everything. And usually, actually a URL ends with a slash. So it should be like this. And so here, let's take that out, actually, and then here as well. Then here, question mark search, and then this one is going to be our query. All right, and so we can then already log that data to the console to take a look at it before we then manipulate it a little bit. And so right now, this should already be working. And so let's, before we actually write any controller or any view, we can already call that function here. So load search results. And then let's try it, as always, with pizza and see what we get. So that's right here. And indeed, this is the result that we get here. So it's coming from model at line 35. So that's where we were. And so here is the data that we get back. So we have an object which has a data property, which then has a recipes property, which is this array. And then each array contains all of this data about each of the recipes. So again, this object here is called data. Then in there is data again. And then in there is recipes, which is then the array itself, where each of the elements is an object with only some of the data about the recipe. So you see, it's not the complete recipe object. It's only some of the data so that we can actually display it then here in the search results. So without the unnecessary data like ingredients and all that. All right, so let's now take this data and store it into our state. And also we will want to change, again, this one here, so to image only. And so we will basically create some new objects based on this data that we receive here. All right, so we get data.data.recipes. So this is the array. So this is the array of all the objects. And now we want to create a new array which contains the new objects where the property names are different. So let's map over this. And each element is going to be a recipe. And then here we will simply return a new object. Let's actually copy the code from here because they are the same, at least some of them. So taking all this, and here now this is only called a rec. Okay, and also we don't have the source URL. We only have ID, title, publisher, and image URL. Okay, So this will return a new array with the new objects. And so now where should we store that? Well, as you can guess, we will put it also in our state. So again, the state contains all the data that we need in order to build our application. So let's call this one search. And all the data about the application that I just mentioned might as well also include the search query itself. So let's create a new object here and then specify the query, which we start as an empty string, and then the results, let's say. Results will start as an empty array. So basically the state should contain all the data really about the application. Now in this case, we might not even need the query for now, but it's still a good idea to already store it here in the state. Because maybe one day we will need it, and then the data is already there for us. For example, we might want to add some analytics in the future to know which queries are made the most. And so by then, yeah, as I said, that would become useful. Okay. But anyway, let's now store this data in state.search.results, right? And here at the beginning, the very first thing that we're going to do is to state.search.query equal to query. All right. And now let's quickly, just to see if everything worked, log that to the console. So state.search.results. And here we are. So that is exactly the kind of array that we had before. And now the image URL we had before is indeed called image. And so everything has the same format as before. So we needed to do that because here the image is also called image. And of course, we want everything to have the same names throughout the entire application. All right. So let's get rid of this because, of course, we want to call this function in the controller. And so let's go there to the controller and basically create a new function, which is going to be like the new controller. So const control search results. And so this one will call the asynchronous function load search results. And so this one, of course, then also need to be an asynchronous function itself. And so, as always, try catch. And here for now, let's simply log the error, and we will then fix that later. So here is where we actually will want to call the load search results that we just built. So that is in model.load search results. And here we then will need to pass in the query, but for now let's just do that again manually. And of course we need to await this, but we do not store any result anywhere because just like the load recipe function, this one also doesn't return anything. All it does is to manipulate the state. And so then we should be able to do this console.log in the controller and still get access to the results, right? So let's see. Now, of course, we first have to also call this function. And again, later we will, of course, hook this up to an event listener. But here, let's just call it right away. And now we get state is not defined. All right. And that is because, of course, it needs to be model.state.search.results. So you see that this is becoming a pretty long chain here. But never mind, that's not a problem at all, because we know exactly what all of this is. And so now indeed we get back our 59 search results for pizza. But now, instead of only searching for pizza, we actually want to get the query right here from this input field, right? And we also want to start this whole process of loading the search results. So we only want that to happen when this button here is clicked. And so now let's basically create a view only for this search part here. So right here, we will have a view for this here, so for the search field and for the button, and then a different view which will actually render the results. So it's a good idea to keep every view really focused. And so it's best to just do one for this part and then one for displaying the results. Also because in the user interface, they're actually in kind of different places also. So it makes sense to have a different view. Now this view here is of course not going to render anything, but what it will do is to basically give us the content of this input field. So getting that input data is of course something that has to do with the DOM. And so it should be in a view and not in a controller, right? So of course, if we wanted to be lazy, we could go ahead and select the element that we want. So it doesn't matter. And then from there, we would simply get the value and then use that as our query. So again, we could do that here, but this is clearly about the DOM. And so in order to follow our architecture, we will create a new view right now. And this one is going to be called the search view.js. And just like before, here we will create a class called search view. And we will then not export that class, but export an instance, so an object that was created by this class. So export default new search view, and without passing in any data. Then, just like before, we will have a parent element. So just like in the recipe view, so a parent element, and then we will set that to something, query selector. And now let's see what we get here in the DOM, so in the HTML. So the search, it's this one. So we have this entire form, which is called search, and which has this input field here and also the button. And so I think that this is the element that makes sense to select. So the one with the class of search. So dot search. So this is our parent element here in this case. Now, again, this class is not going to render anything. All we want is to get the query and eventually to also listen for the click event on the button. But let's start with the query here. And so let's create a method that we will then call from the controller called getQuery. And all this will do is to return this dot parent element. And so again, that's going to be the search. And then from there, we want to select this input field. So this one with this class. And so let's select this child element using query selector. And then simply get the value of that. Okay, and that's actually it. And again, of course, we could have written this exact same code in a controller, but that wouldn't make any sense because this is not concerned about the DOM at all. So we don't want to have any DOM elements in here. We don't even want to know what the DOM looks like. So actually here we have this, but we don't want this here. Let's get rid of all this clutter here actually. And now I want to get the search view here. And then here we can get that query by saying search view.getQuery. And of course, there might be no query. And so let's add another guard clause here. So if there is no query, then return immediately. And so here we will now no longer look for pizza, but for query. Now, if we run this, then of course there will be no result because, well, right now there is nothing here to be found. So that controller function runs right in the beginning when the application actually loads. And so by then, of course, there is no value here. And so in order to actually make this work, we now need to listen for the event of basically clicking this button or submitting this form. And then only on that event, we want to actually call this controller function here. So not in the beginning when the script loads. So in order to do that, we will once again use the publisher subscriber pattern. So basically exactly what we did here, right? So we will listen for the event in the view right here, and then pass the controller function, so the handler function, into the method that we will build here. So this add handler search method here is basically going to be the publisher, and the control search results function is going to be the subscriber. Okay, so hopefully you really understood that pattern that we used before, and so this now should be obvious. So let's take our parent element, so this dot parent element of course, and then this is where we will actually add the event listener. So not to the button, but really to the entire form, because there we can listen for the submit event. And so then this will work no matter if the user clicks the submit button or if the user hits enter while typing the query. Now here we cannot simply call the handler immediately, because remember, as we did many times before, when we submit a form, we need to first prevent the default action, because otherwise the page is going to reload. So prevent default, and only after that we can call the handler function. And as you already know, this handler function should be the control search results function. And so all we have to do now is to call this method and pass in that function. So let's do that here right at the beginning. So search view dot add handler search. So you see that I'm always going to use this name here of add handler. And then we pass in the controller function. And that's it. So now it should actually already work. So let's see, and actually let's clear up all this clutter here a little bit. Okay, so this console.log, and there's also some here in the recipe view. So that's this one. Okay, so let's again try pizza. And yeah, beautiful, it worked. So we get this data first here coming from the model, and then also in the controller we also logged it. And so here we have the exact same 59 data that we had before. Let's try something else now. Avocado, let's say. So I hit enter, and so this time we got 39 search results. And you see all of them basically have avocado right there in the title. It's really beautiful that it already works this great. Now just one small detail is that after we search, we should probably clear out this field. So let's add another small method for that in the view. So in this one here, so clear input, and once again, having it nicely encapsulated inside of the search view. So again, this could simply be also in a controller because it's really just one line of code, but we want to keep everything separated. This will make it so much easier to add features in the future. and it's really so much better. So all we do is to set this to empty, and that's it. All right, let's try it one more time. Let's say pasta this time. Of course, we never called the method here anywhere. So we need to do that in the controller. And let's actually add some more comments here. So get search query. And the code itself is actually pretty self-explanatory. And so many developers will tell you you should not comment it. But I think that this is actually very helpful when you read the code in like 1 or 2 years from now. So I would advise you to always write comments like this, even if your code seems pretty obvious, especially when it's like a bigger list of instructions like this. So render results. So right now our rendering is only a console.log. But here, when we get the search query, we can actually then immediately also clear it afterwards. Or in fact, in order to keep this controller even simpler, we can do that right in the getQuery method. So let's go back here. And now we can make this private, so we're not going to use it outside. And then let's actually call it here. So this dot clear input. And then, of course, we first need to store this somewhere here. So we get the query, then we clear the field, and then we return the query. All right, so that should now work. So pasta, it clears the field and gives us our 45 results down here about pasta. Great. So that works just fine. And so all there's left to do is to now implement actually the view. So the second view basically, so the one that is responsible for then rendering all the results here in this sidebar. And so that's going to be a little bit of work. So let's leave that for the next video. Let's now render the search results by creating a new view. So we already have the search view, but now we also want to create like a results view. So a results view which will contain a render so that we can then call that render here with these search results. So similar to what we have here, so to the recipe view, which also has a render method which takes in some data. And so now, again, we want the same for a results view. So we also wanted to have a render method which takes in data and which is then rendered to our user interface. So let's create the results view.js. So results view. And so now this view will actually be pretty similar to the recipe view. So we don't need that one anymore. But now, again, this one is going to be very similar. So we will have a parent element, data, these messages. We will basically also need the same render method, the same render spinner. So we will need to display the spinner while the data is being fetched. So in this case, the search results. We might need to also render an error. And so now it's time to basically refactor this code and create a parent class. So I had mentioned that before, but now it's actually time to do it. Because by creating a parent class, we will then be able to reuse all of these methods on all the views. So basically on all the objects that are created through all the view classes. So let's create yet another file here. And I'm calling it view.js. And so let's create a new class here called view. And so we will then export immediately this class. And actually, let's make it a default export. So this time we are actually exporting the class itself because, of course, we are not going to create any instance of this view. We will only use it as a parent class of these other child views. All right. Here in the recipe view, let's now import that parent class. So import view as, or actually not as, but from view. And actually we don't even need the JS, but I like to keep it there for consistency. And so now all we need to do is to basically copy everything that should be common to all the views to that parent class. However, there is one thing that we still need to change here. And that is that right now, with parcel and Babel, inheritance between these truly private fields and methods doesn't really work yet. So here it was nice to actually use the native way of JavaScript of protected methods and properties, but now we cannot really use it anymore. So maybe that might be possible at some point in the future, but for now we will have to go back to protected fields and protected methods. So let's basically select all of these hash symbols, and actually I will select them like this, so with the dot, because otherwise that will also select these ones. So hitting Command D here a couple of times, and then replace it with dot underscore. And now we just have to change these method names. So changing from truly private to only protected using the underscore convention, and then the same right here. Okay. So now our code should still be working. It says here connection lost, but indeed our code keeps working here. Okay, let's just check out the search view. And so let's use the same convention here as well. Okay, just here as well. And now here we also converted everything successfully. But anyway, let's now basically extract the view class from this recipe view. So what we need in all the views is this render method, then this one as well, this one, and basically everything except for generating the markup, because that of course is going to be unique to every single view, right? And also adding the handler. But everything else we want to be the same on all the views. For example, rendering the spinner will be really easy. So all the views will simply have this method, and we will then be able to call it on that method. And thanks to the parent element property here, it will then know exactly to which element it should attach the spinner. Because again, the parent element, of course, will be unique to each single view. So the parent element will be unique, the message, so these two messages, but this data can actually also be on the parent. So let's copy all of this here, or actually cut. So everything except for adding the handlers and generating the markup. So let's put that here. And here we of course then need to extend this one. So extends view, right? And so let's see if we have everything still in place. Yeah, so I'm confident that this will work now. So let's see. Oh, and icons is not defined. So let's go back here to our view where we will have to copy this one. because here, of course, we are also using the icons. Okay, but here it is. All right, so we successfully extracted the view class from the recipe view. And now all that's left here is really what is unique to this view. And so this makes this even easier to work with, in my opinion. Because now let's see what we can do here. So even without any code yet in the results view, we will already be able to add a spinner to the search results. All right, well, we cannot really leave it empty. We still need actually the parent element here. All right, and we also need to import the view. So import view, and then this is just another child class of view. Then here we need to say that parent element should be, well, something, and let's check out what it actually should be. So here in index, let's see. So it's this here. So this result element, so this unordered list. All right, and then basically each of the search results will be one of these preview elements. But more about that later. So for now, let's just set the parent element to this results elements here in result view. So document.query selector results, and then we have to export default just like before, and then a new instance of this view. And so this way there can only be one results view, and then here in the controller we can immediately import that without having to create the instance here manually. So that's results view like this. And so now here we should already be able to load the spinner, or actually to display the spinner. So let's do that at the very beginning. So results view dot render spinner, and let's see what happens. So pizza, and here is a small error. And so let's once again do some debugging here. And I hope that you can appreciate that I'm actually not cutting out all these like small debugging sessions so that you can actually see what I'm doing here. But anyway, apparently the problem appears here in Vue.js at line 14. So right here, so it seems like it cannot find the parent element. So let's simply log that to the console. So this here is the result of doing that for the view. And now let's see. So now that is undefined. So to me, it seems like here we selected the wrong element here, maybe. So results. So that should actually be correct. And so should the name. So I think parent element is correctly spelled. Oh, but it's actually called parent element all written out. Okay. So you see it's actually called parent element like this. For some reason I thought it was called just like the abbreviation. Ah, and you see here is the nice loading spinner spinning away here in our search results, right? And again, all without writing any new code for displaying that spinner here in the results view, because it is now simply inheriting that method, so that render spinner method from its parent class. So let's get rid of this. And just for the sake of curiosity, let's actually take a look at this results view. So just so we can see the whole prototype chain here in the console. So for that, we need that controller to run. And so here it is. So you see that we have still some undefined data. Then we have the parent element, so the one we selected. And then we get, well, right now we don't have any methods in the class already, but we do have methods in the parent class. And so these are the ones, right? So the render one that we're going to use next, then render error and spinner and message. So it's always good to remember these things so that we still know how everything actually works behind the scenes. But now it's actually time to create basically this generate markup method also in the results view. Okay, so all the child views should have this method here, because in the view, the render method then actually relies on that. Okay, so this dot generate markup needs to exist in order for the render method then being able to create the markup and render it, or to insert that HTML into the DOM. And so let's take that, just that name, and create that right here. So as always, add template, literal, and then now it's time to actually get this code here. Okay, and this here is called a preview because we will actually use the same thing later here to render the bookmarks. So that's going to be a nice trick, but we will save that for the future. Okay, some more indentation here on all of this to make it look great. And so now we need to take our data and actually put that right here. Now, where actually is that search results data? So with all of this structure, it might be a little bit hard to follow where that data is. So let me actually start by calling the render method here. So here, besides of simply logging the search results, we now also want results view dot render, because of course, just like render spinner, the results view also inherits render, and then into that we pass whatever we want to be rendered. And so that is all of this. Okay, and then in the render, here we see that it takes this data and puts it into this .data. And so here, if we then take a look at the results view, let's simply log that then to the console. So this .data. And so this .data here should basically be exactly this search results. So let's see. And it is. So you see that twice we now get this array. And you also see that it already printed something here to the results. So that is that pre-formatted HTML that we already created here. So it's already basically this HTML, right? Because this method here is already returning that. And so then the view takes that data and renders it on the user interface. Okay. And so let's now actually create this method. Now, this is actually an array now. And so here we need to loop over that array. So in fact, we don't want to return simply this, but instead we want to return a whole string which contains like one of these elements for each of the search results in the array. So we will return basically this .data, and then we map over it. Remember? So we did that before with the ingredients. And then at the end, we join everything together. And so then that will be the string that we return here. Now, we could now go ahead and put this code here into the map function, but instead I will create just another method down here to make this a little bit cleaner. Let me copy this name, preview. And I'm simply calling it this because that's also the class name. So let's put this one here. And so then here we can call the method. Oh, what was that? So we can call it right here then. And so now this should like print 50 or 60 of the same. So just to see if it works. And indeed, here it is. So 59 results, and so it prints this 59 times right here now. Right? Now all we need to do is to fill it with the real data. So with the ID, image, publisher, and title. Okay? So to start, we need the ID here in order to build the link. And so then when we click the link, that will change the hash in the URL, which in turn will trigger loading a recipe. So that's what we did by the beginning of this section. Now here we need to pass in the result then. And so here that is result.id. Then here it's the image. So .image, here it's the title. And then here the publisher. Okay. Now here we also need to replace the icons. So we will need, again, the icons right here. We will probably need them in all of them. So but that should be it. And it works. Beautiful. So we get all of these search results here. We just have to fix some small details. But you see that it's already working. And now let's click on one of them and it works. Minimizing this a little bit. And so you see that now we get exactly the recipe that we are clicking on here. So watch what happens with the ID when I click here on pizza casserole or casseroli or whatever. So it changed the ID up there and changed the recipe here also in the view. Great. Now let's just fix this icon here and actually also here. And then also all of these should not be highlighted. We will take care of that a little bit later. So we need to take away this class here of active. And here we also need to take away this. Okay, and we will come back to this later again when we actually start to implement uploading our own recipes. And here in the alt text, we should just put that title as well. Okay. Now you see that actually the state that we had here before in the page is gone. And so let's activate that hot module reloading that I mentioned in the last section. So remember that with parcel, we can do this. So if module.hot, then module.hot.accept. All right. And again, this is not real JavaScript, at least this module.hot. This is simply coming from parcel. All right. And now finally, let's also delete these fake links that we had before. Let's reload. And that looks a lot better. Okay. So let me now change something in the code. For example, getting rid of this console.log here. And so previously that would then reload the entire page. But now as we go back, you see that the state here actually remains. All right. All it says is the console was cleared, but that's it. So the rest remains the same. And we can now also delete this user icon from the recipe view. So Let's see where that is. It is simply this div here. And so once again, it will now not re-render everything. Well, maybe we should re-render. And yeah, now it's gone. Well, it also messed up our button here for some reason. So maybe that was not intended. Maybe I should just remove this here. So basically keeping an empty div. Okay, so for the time being, let's just leave it like this. Okay, now let's just see what happens when we search something that for sure does not exist. So you see that here we still get a success. You see? So we still get that data, but the only difference is that the recipes array is now empty. And here we also see that the array is empty coming from the state. So in this case, we actually want to render like an error message here saying that there was no results for that query. So let's start by creating also the error message property here. So let's copy these two actually to our results view. And here let's say no recipes found for your query. Please try again. But now, how exactly will we actually display this error message on the parent element? So we could do that right here in generate markup and basically check if the array is empty, and if it is so, then render the error message. So that would work. However, we can also do that directly in the render method. So automatically, right as we receive the data. And I believe that is what makes more sense. So right in the beginning, when the render method is first called and receives the data for the first time, we can immediately check if that data actually exists. So right now, we only simply assumed that there always is data and that we can then generate some markup with that data. But as always, it's a good idea to check if the data actually exists. And that is true no matter if we receive a simple object or if we receive an entire array of objects, which is the case of the results. So let's add a guard clause here. So if there is no data, then we want to return immediately, and we also want to render the error. So we can do that all in one line, and this will then still work. So this dot render error, and we actually don't even have to pass in any message because we already automatically get the message from this dot error message. And so in this case, that is going to be this one that we just specified before, right? Now, however, in this case, this check is actually not enough because in fact, we do get data. It's just an empty array. And so in this case, we also want to treat the empty array as though we had no data. So this here basically only works for undefined or for null. But now we also want to check if the received data is an array and if it is empty. So we can do that by saying, so if there is no data or, and then basically if the data is an array and if it's empty. And we can do that by using a helper function that is on the array constructor, which is array. So we can check that. And so if it's an array and the length of the array is 0, basically, data.length 0, well, then in this case, exit this function immediately and also render the error. Okay? So again, if there is no data, or if there is data, but that data is an array and it is empty. So in both these cases, we want the error to be shown. So let's check that. So with pizza, it all works the same because there are results. But now with this, there are no results, and then we get our error message. So, great, that works. And so I think we are done actually with this part. So just one more look at our flowchart. So we implemented the event that the user searches, we asynchronously loaded the search results, and then we also rendered them to our user interface. And so with that, we are done. Right? Just a final look here at the controller, but everything looks good. So in the next lecture, we will actually take care of the problem that we have these 59 results all one after another here. So that's not good. And so we will implement pagination in the next 2 lectures. Welcome back to the next feature of the Forkify application. And this one is going to be pagination. So let's take a look at our current implementation of the search to get an idea what the problem is. So you see we have 59 results for pizza, but now all of these results are displayed here basically at once, right? And so this is not user-friendly at all. So in the final demo application, we only have 10 results on this page, and then we can go to the next page and basically get the next 10 results. And so that's what we want to do right now in our application as well. Now this problem is actually harder to solve than it might seem like. But I'm sure that together we can do it. So let's think about what we have to do here. So remember that it is the control search results function that is responsible for rendering the search results right here. And currently, we are simply rendering all the search results like this. However, in the first page, we only want to render 10 results and not all of the results, right? And then, if we're on page 1, we want to render the second 10 results. So from result 11 to result 20. And so, let's basically create a function in our model which will take in the page that we want to render and which will then only return the results that we actually want to render for that page. Okay? And that's actually not so difficult. So let's create a new function here and also export it. And let's call it get search results page. So a function. And this one is of course not going to be an async function because we already have the search results loaded at this point. So at the point when we will call this function. All we want to do in this function is basically reach into the state and then get the data for the page that is being requested. So what we will return here is basically a part of the results. So let's write that here because that will be helpful to understand the logic we need to write here. So we will return state.search.results, which remember is this array here, right? And then we only want to return part of it. And so that's a slice. So again, for the first page, we would like to return from result 1 to result 10. And so that would be 0 to 9, actually, because the array is 0 based. Now, of course, we're not going to hard code these values here, but we can basically calculate them based on the page. So let me try that. So we will basically create a start variable. So let's set that to 0 for now. So basically having the same values as here. And also an end variable. So we want to start at a certain point and then also end at a certain point, right? But again, we don't want to hard code these values, of course, but instead we want to calculate them dynamically. So here we will want a 9 and here a 0. And so how can we calculate that? Well, the easiest way that everyone does it, or at least I think that's the way that everyone does it, is to take the page and then -1, and then simply multiply it by the amount of results that we want on the page. So let's say 10 here for now. And then here we do the same simply with page. So page times 10. Okay. So let's say that we requested page 1. So 1 minus 1 is 0, and 0 times 10 is then 0. So just as we wanted. And for the end parameter, then page is 1 times 10 is 10. And actually the slice method here does not include the last value that we pass in. And so actually 10 is perfect here. So that will then extract all the way to 9. Now, one page is 2. So for page 2, then here we will have 2 minus 1 is 1 times 10, 10. So it will start at 10 and then go to 2 times 10, which is 20. And the same for all the other pages that we pass in. And so this is actually already it. Now let's just refactor this code because, of course, this here is an important data about our application. And so it should go into the state. Okay. So let's call that results per page. And so let's set it to 10. So here instead of 10, we have state.search.results per page. So that's a lot better. But actually we can do even better because this here now looks kind of like a magic number, right? So a number that comes out of nowhere. And so I think you can see where I'm going with this. So I will create another constant in our configuration file. And then if at some point in the future we want to change the configuration, in this case of the results we want per page, we can simply come here to the configuration file and change that. So let's import that. So that's right here. Replace that here. And so that should work just fine now. Okay. And now let's go back to our controller. And so again, this is the way we did it previously. So all the results, but now we only want some results. And so we can now call that function that we just created. So model.getSearchResults. And then let's say we want to start with page 1. And of course, we will then later on get this value here dynamically. But for now, we just want to see if this actually works. So let's see. And let's search here again for pizza. So again, 59 results. But we still get all the results here for some reason. So let's only log this here to the console. So just to see what our function here is doing. Well, apparently it doesn't really do anything. So get search results per page. I think that is the correct name. So that should actually work. Well, let's just log something here just so we see if this function is actually being executed. So start and end. Well, nothing is happening here for some reason. Maybe we need to stop parcel. Sometimes that is necessary. And then run it again. So let's build it all again. Let's also try it again. And now it seems to work. And indeed, now we only get 10 results. So sometimes you actually have to stop and restart Parcel. This isn't the first time that this has happened to me, and probably I should have warned you about this problem also earlier. But anyway, now we see that this actually worked. So great. Then we can get rid of this and also of this console.log right here. Okay, now let's try something else, like page 2. But apparently it didn't change anything. Maybe we just have to turn off the hot module reload. Let's try that. Now I think that these 10 here are different. Or are they? Well, I'm not sure. Let's try page number 3. So we started with pizza dip. So let's see what we get this time at first. Yeah, so these actually look new to me. So it looks like currently we are indeed on page number 3. Okay, and now just to finish this part, here in our model, we should also store this page number that is coming in this state. And that's going to be important because later when we will display the page number here, then we kind of need to know at which page we actually are. Okay, and so this really makes sense because again, this is a very important piece of data about our application. And so it's good that in any point of time, we can know in our application on which page we currently are in the search results. So let's simply say state.search.page is equal to page. And then let's actually also set it up here. So the page, we can set it to 1 by default. Okay. And then finally, we can make this even better and say that by default, the page should be that default. So state.search.page. And so now if we don't pass anything into the page, then the page will simply become the default of 1 that we just said before. So we can remove that 1 from there, and it should then still be working in our own version. So pasta this time. And yeah, so here we get our 10 results. And so we are done with this part, but this was actually the easy part because now we need to render the pagination buttons here. And so let's leave that for the next video. So let's now finish building the pagination feature. And for that, let's actually think about some different scenarios. And to do that, I will actually come here to the demo. So the buttons that we want to render down here are not always the same. So in this first scenario, we are on page 1. And so therefore, only this next button here is showing, right? But there is, of course, no button to go back. Now, if we had actually less than 10 results, so basically only one search page, then there would be no buttons at all. Then, if we are on some other page, which is not the first page, well, then we have a button to go back and one to go forward. So that is basically the third scenario. And then if we go all the way to the last page, then we only have a button to go back. And so we have to account for all of these different scenarios. Okay, so let's go back and basically implement a new view for this pagination. So here in the views, we create a new file called paginationview.js. And here let's actually copy some code from here so we don't have the same work over and over again. then of course this one here is called pagination view, and the parent element is not this one. So let's go check out our markup. And so here we already are at the right element. So you see that after this unordered list of results, we have this div element with the class of pagination. And so then this one here already contains the template for a button to go back, so to the previous page, and one button to go to the next page. So we're going to need this soon, but for now let's just complete this setup here. Okay. And so now, just as all the other classes, we will have a generate markup method here. Generate markup. Because remember, that is the method that the render method is going to call in order to generate the markup for the view that we're working on. Right? So again, every view, at least every view that renders something to the user interface, needs a generate markup method. So that's this one here. And so now let's account for these different scenarios that we just saw. So let's say the first one is we are at page 1 and there are other pages. Then the next one is we are on page 1 and there are no other pages. Then there is the scenario that we are on the last page, and also the scenario that we are on some other page, basically. So other page like this. Okay, so what data do we need in order to figure out if we are on page 1 and if there are other pages? Well, for that, we are going to need basically this entire search object here. So this contains all the search results, also the current page and the results per page. And so we will need all of this data in order to compute which buttons should be displayed. All right. And so let's actually go to our controller and already call the render function so that we can pass in the data that we need and so that we can then use it. And well, when do we actually want to display the pagination? Well, it is actually right at the moment when we are also displaying the search results. So we will actually do that right here after displaying the results. So we get the search query, load the search results, render the results, and then also render the initial pagination buttons. And so now here we actually need to export this view so that we can then import it into the controller. So just like we have been doing in all the other views, we say export default and then a new pagination view object. And so then we come here and import that. So results becomes pagination. And now, of course, that view has a render method on it. So pagination view dot render, and here we need to pass in basically the entire search object. So state dot search, and actually that's model dot state dot search. And so now, through the magic of this view class here, we now get access to this data that we just passed in this dot underscore data. Right? So right here, this dot underscore data is now the entire search results object, basically. So in order to figure out if we are on page 1 and there are other pages, we need to know how many pages there are. So let's compute that. So const num pages. And how do we actually know the number of pages? Well, basically we need the number of results divided by the number of results per page, right? So for example, if we had 60 results and 10 results per page, then we had 6 pages. So the number of results comes from this dot data dot results. So let's check that in the model here again. So results, again, is the entire array which contains all the search results. And then we also have results per page, which is this configuration constant that we set to 10. Remember? So let me copy this. And then here we will divide that. So this dot data dot results per page. And this is a very important variable. So let's start by logging it to the console. And with this, we will then also know if we correctly hooked everything up here. So basically, if this render here of the pagination view is already doing its work. So let's see. Searching for pizza. Well, here we get some not a number. And of course, well, here actually we already have something rendered. And so that's undefined because right now we are not returning anything from this function. And so if we don't return anything, by default, undefined is returned. And so that's 10 basically rendered here to the page. But anyway, what matters here is that for some reason we got not a number. So that means, and I know why here. So here, this is the entire array, right? So we are dividing this array by the number. But of course, what we want is the length of the array. So let's try that again. Yeah, now we get 5.9 pages. And of course, we now need to round that to the next highest integer. And so for that, we simply use math.ceil, remember? And so this will now become 6. Okay, so let's do some check here. So if we're currently on page 1, which is this dot data dot page equals 1. And so now it is very important that we actually have the current page in the state, right? So that's why we put it right here. So whenever the get search results page method is being called with some value. So just to illustrate this, let's actually render the results at page 2. Just to then test if what we have here works. But anyway, here we are testing if we're on page 1. And so that's this.data.page equals 1, and there are other pages. And so basically that means that the current page needs to be less than the number of pages. And so that basically means that number of pages here is greater than 1. So num pages greater than 1. So this is our first if check. Let's actually log that to the console. Page 1 and others. Or actually, let's even return that string, because we already know that this will then get printed. Even though, of course, this is not at all what we want. Now this one here we will leave to the end. So let's continue with this one. So being on the last page basically means that the current page is the same as the number of pages, right? So data.page is equal the number of pages. So in the current example, we have 6 pages. And so if the current page is number 6, well, then that means we are on the last page. So here let's return last page. Then here some other page basically simply means that the current page is less than the number of pages. And if any of what I'm saying doesn't make sense, then probably the best thing to do is to pause the video and think about this on your own. So that's always my advice. So basically reflecting on what I'm saying is usually the best solution to really figuring out what exactly it is what I'm doing here. So of course I'm trying my best to explain everything, but at a certain point you also have to take a look at the code and think about it on your own a bit. But anyway, this actually already covers all of the scenarios. So if none of these scenarios here is met, then that basically means that we are on page 1 and there are no other pages. And so in this case, we can return only one page. And actually that is not really true, because let's say that we only had 1, so that num page would be 1, then actually this here would also be true. So here we have to add the same as before. So num pages needs to be also greater than 1. So then we are really on the last page and need to render some other buttons. So, but to test this, let's keep in mind that we are currently on page 2. And so therefore we want to now see other page rendered. So let's see. And indeed, there we have other page. Now let's try page number 6. So here we see we have 6 pages. And so now it says last page. Great. And now page number 1. And so one more time. And so page 1, but there are other pages. Great. So this was, I think, the hardest part. So figuring out these different scenarios. And now all we need to do is to create the markup. So let's come here to the HTML and grab this code. So this is the code for going to the previous page. So when do we want to go to the previous page? Well, for example, right here on the last page, right? So here, in fact, we only want exactly that one button. Now, what is the page here that we want to go to? So we need this number here. Well, that page is basically the current one minus 1. Right? So we are using this data.page a lot of times. So let's store that in a variable. So yeah, const current page is this. And so now let's replace that everywhere here with current page. So here we will then want the current page minus 1. And here we need to replace the icons. Okay. Then here on page 1, we basically need the opposite. So again, we only want just one button, but the one to go to the next page. So let's grab it. And actually it's almost the same markup. So another nice template literal. And now here it says page 3. And so of course, here we will now want to go to the current page plus 1. Right? And then here again, we need to replace the icons. Okay. And then here for the other page, we want basically both of them. So let's return this, or actually this one here. So first the button to go back. And then also add the button to go forward. All right. And then when we're on page 1, then we simply return nothing, because here we don't want to render any button. So if there are no other pages, there's nowhere to go, of course. All right. So let's see what page we are currently on. So page 1. And so that should render. And so that should render then this button here. So saying page 2. So let's see. And indeed, page 2. Now, of course, if we click here, then nothing is going to happen. But for now, that is not the point. Let's try page number 4 now. So go back to page 3 or forward to page 5. So beautiful. So it looks like it's working. Let's just try the last page here now. Oh, what's going on here? And indeed, it says to go back to page 5, but no page to go forward. So that's awesome. Now the next thing that we need to do here is to then add an event listener to these buttons so that we can then actually go back and display another page. So right now, this is not useful at all, but at least we already have our buttons here showing up right in the beginning when the search results are loaded. Okay. Now, this code here could of course be refactored because we are repeating a lot of code here. So this button is the same as this next button, and the previous button is also the same here. Okay, so we could refactor that, but I will actually not do it here and instead leave it for you as a challenge. So you might create a method called, for example, generate markup button, and then refactor that code in that method. But here, I'm not going to waste any more time, and instead I will go immediately to adding the event listener. Now, just like before, we need to use the publisher subscriber pattern, just like we did, for example, here in the recipe view. Remember? So again, that works by creating a publisher, which is basically a function which is the one listening for the event, which receives a handler function, which in our case is going to be a controller that lives here in the controller. And so with this, we will then be able to listen for the event here in the view where it makes sense, while at the same time being able to handle that event from the controller, basically. Okay? So let's add that method here. So add handler, and I'm just calling it click. So for click on one of the buttons. Okay? Now here we are going to use event delegation because there are going to be two buttons, but of course we don't want to listen to each of them individually. So instead we will add the event listener to the common parent element, which is indeed this dot parent element. So dot add event listener, and this time finally listening for a click. And then here we have a function, because we cannot immediately call the handler that comes in here, because first we will need to figure out which button was actually clicked based on the event. So that's event delegation, and I hope you remember how it works. So in this case, we can simply create a button element and select the closest button element to the clicked element. So the clicked element is e.target, and then closest, which is really an amazing method. And so here we can now basically look for this button. So for the element with this class. All right. So remember that the closest method is a little bit like query selector, but instead for searching down in the tree, so for children, it basically searches up in the tree. So it looks for parents. And this is important because here in the button, we might actually click on this span element or on this SVG or this use instead of clicking on the button itself. So we cannot simply set the button to e.target, but we actually need to search for the closest button element itself. And just to see that this works, let's actually now create our controller. So here we will then log that button to the console only for now. All right. And so now let's go to the controller and as always, create a new controller here. So basically this is the controller that will be executed whenever a click on one of the buttons happens. So control pagination is a function which for now doesn't really do anything. Let's just call it pag controller. So simply logging this to the console. But what matters here is that now we call the pagination view and add handler click. And so this will then, of course, call this function here, which in turn will call add event listener so that we can start listening for the click event on this pagination element. Okay. Now here we also pass in the handler. So that's control pagination. And so just again to check if everything is working, let's simply also call that handler right here. So once we click on the button now, we should see this button logged to the console, and then also the handler function should run, which is of course this one. And so that should then log pag controller. So let's see. So looks like we're still on the last page. Let's click and yeah, so everything works as expected. We have the button correctly selected and it also says pagination controller. Great. So now we have the click on the button. So it is correctly selected, but why did we actually select the button? Well, we need a way of knowing which is the page where we need to go now. So it says here page 5, but how will JavaScript know that it should now actually display the results of page number 5 here? Well, this is where we one more time need to basically establish a connection between the DOM and our code. And so remember that we can do that using the custom data attributes. So what we will do here is to create a data attribute on each of the buttons, which will contain the page that we want to go to. And so then in our code, we can read that data and make JavaScript or make our application go to that exact page. And so this is basically the final piece of the puzzle. Okay. So here in our button, let's now add that data attribute. So data, and I'm going to call it go to. And so the page we want to go to is exactly the same as this one. So basically exactly the same that it says in the button text itself. So now let's copy that everywhere. Here it is page number -1. Here again -1. And then here on this, it is page +1, right? And so then here we can actually get that number, of course, from the button. So let's call it go to page, and it is button dot data set dot go to. And then let's log that to the console. All right. And actually, let's go to some other page. So basically start this here on page 4, just so we have 2 buttons. Very weird what's happening here with the scroll. But anyway, here we have now the buttons for page 3 and 5. So let's click. And indeed, here we have the 5. And we also successfully read the 5 here. Now you see that this is here like kind of in this white, while this here is purple. So remember that purple here means a number. And so this is still a string. And so we will need to convert that. But another thing that I wanted to show you is that, of course, we can also click outside of one of the buttons, right? And so then here the button is, of course, null, and we get an error by trying to read the data set. So let's first convert that value we get from the user interface, but all of this should only happen if there actually is a button. So yet another guard clause here saying if there is no button, then return immediately. Okay. So let's try another one now, pasta. And if we click now, then here we get the number 3 and here the number 5, right? So what are we going to do now with this number? Well, we can simply pass that number back to the controller, basically. And then in the controller, we can finally use that number to actually render the results on the page that we want by using, again, this method here. All right. So these pagination and results controllers are kind of intertwined. So I think that this is a little bit confusing because of that. But if you analyze all of this here, maybe afterwards, you'll see that it makes sense. So we already see that here in the controller, we are rendering the pagination in the beginning. And so here in the pagination, we will later render the new results. But let's not get ahead of ourselves. And so what I want to do now here is to actually pass that page into the handler. Okay. And so, of course, our handler now needs to accept this value. So let's call it again, go to page. And just to see again if this works, log that value to the console. Okay. And indeed, we get page number 5, which is the button that we clicked on, coming from the controller this time. And now, finally, what should actually happen here on the user interface once we click this button? Well, we should get the search results for page number 5, and they should be rendered here, right? And then also new buttons should be rendered too. So this should then change to page 4 and this to page 6. Because when we go forward, then these two values here are, of course, going to increase. Okay, and so let's simply do that. And we already know how to do it because we already did it before. So remember I said we want to render the results and we want to render the pagination buttons. And so that is exactly what we already have here. And so let's simply copy and paste it right here. So let me change this here to render new results. And then here, render new pagination buttons. And then here, of course, we want not number 4, but we want go to page. And then here, rendering the new pagination buttons is actually going to stay exactly the same, right? So when we do this here, so get search results with this new page, let's say 4, then here in the model, state.search.page gets updated to that new value, right? So the state.search object is then different. And so that is the object that we then pass into rendering the new pagination. And so therefore, it will then render new buttons because the page before has been changed. Okay. And so this should now actually work. Just keep in mind that we will again start at page number 4. Well, let's actually make that page 3. Oh, and before actually checking out the results, I just wanted to say that this actually works because renderer will basically overwrite the markup that was there previously. And the reason for that is that we here have the clear method. And so before any new HTML is inserted into the page, the parent element is first cleared. So it's first emptied, right? And so then that means that render here basically overwrites everything that was there and puts the new content in the same place. But anyway, let's make sure to reload pizza, and we are at page number 3. And now let's see the magic happen. And I hope we don't have any bug here. And it works. So beautiful, beautiful. And congratulations also for you to following up until this point. So this is, I think, up until this point, the most impressive work that we have done. So you see, everything updates here just as expected. We get new content. And now page 6, you see here, will be the last page. So let's see. And yeah, so now we don't have the last button and we can only go back to page 5. So now let's go to the first page. And indeed, we can only now move forward and get the first 10 results here. So really great work here. I'm really happy about this progress here. Now, just to make sure, one more thing. Let's try this here with results per page of a different value. So let's say that we actually wanted like only 5 results per page. So then we should get a lot more pages. And so it's important that we check that that actually works. So you see that it does actually work already. So we only have 5 results here now. And we can also already see that we will have 12 pages. Oh, and we are still on page number 3. But now we will be able to go back, or actually to go forward to page number 12. And so each of these pages only has 5 recipes. And now let's just try to search for something that is not very common, like dip, for example. And, well, we still have a couple of pages here, actually. But before we go any further, let's put this here actually to 0, or actually to 1. And remember that passing nothing is basically the same as setting it to 1. So let's try dip here again. But it seems like we have still 6 pages. So I just wanted to find some search term that only has 1 page. Let's try hummus maybe. But we again have 4 pages. Well, we can fake that by having 50 results on 1 page. And so with this, we should already only have 1 page with pasta. So pasta has 45 results, but here we want 50 on 1 page. So we only have 1 page, you see, and indeed, no buttons. Great. Let's put it back to a meaningful value, so 10. And so with this, we are actually done. Let's just clean up our code here a little bit more. But I think that with this, we are now good to call this finished. And actually, we finished now the entire part 1 of our flowchart. Right? So this was already done this here as well. And now, here what we did was to listen to this event, then render the pagination buttons, and of course, render the corresponding search results. So all of this is now in place, but I ask you to really analyze again the code that we have here in control pagination, as well as here in control search results. Because again, these two controllers, they're kind of intertwined. So they both are doing similar things, at least when it comes to displaying the pagination and the results themselves. So it's very important that you understand the flow of this data here, especially of this go to page. Okay, and then maybe also analyze again how all of this here works. But then you are good to go to the next video. And so there we will discuss basically our next step, what we should do next. So that next video is going to be a lot shorter so that we can finally take a break from this application. So again, analyze this like I told you to, and then after you're ready, let's go move on to our next part of the flowchart. So we have been making a lot of progress in building our application. And we can actually say already that the core functionality of the app is in fact already working. So now let's take a breath and think a little bit about our next step in this short lecture. So again, the core functionality is what we see here in this flowchart. And so that is basically the search functionality, then also displaying the pagination, and then displaying any recipe that was selected. And so that we already have working at this point. And so that is really great progress. But now let's take it to the next level and think a little bit about how we will implement our next features here. So based on the user stories that we outlined in the beginning of this project, our next feature was a functionality for changing the servings of the displayed recipe. And that's going to be quite easy. All we will have to do is to listen and to handle events on the change servings buttons, and then basically update the recipe and render it again. Then the next feature is the bookmarking functionality. And this is going to be yet another one that will be a little bit complex to implement. So let's see what we have here. So starting with the event here more on the left side, whenever the user bookmarks a certain recipe, then we want to render that bookmarks in the special bookmarks panel, and we also want to update the button in the recipe. And so basically we will then re-render the recipe. Now then, whenever the user clicks one of the bookmarks, and so that's the other event down there, then we want to render exactly that recipe that was clicked. Okay, so here we will need two events, and by the time we reach this functionality, we will of course see in more detail how it's going to work. Then next up, we want to be able to store this personalized bookmark data in the browser and also read it back when the page is loaded for the next time. And so that's exactly what is here on this diagram. So whenever there is a new bookmark, we basically store all the bookmarks to local storage, and then when the page loads, then we load all the bookmarks back from the local storage and render them. All right? And so that's actually it. So this is what we will do over the next couple of lectures. And once we're done with that, the application will actually almost be finished. Okay, so that is our plan for the next couple of lectures. And so let's now go back to code and implement the functionality of changing the servings right in the next lecture.